Hello there and welcome to Science for Sleep, where curiosity slows down, the universe feels a little softer, and even the strangest corners of science are allowed to unfold at a gentler pace. Tonight, we're going to spend some time looking upward. Not in a dramatic hurry, not with countdown clocks and blaring alarms, but quietly, the way humans have always looked at the sky when the world grows still. Because most nights, space appears calm. The stars hold their positions. The moon keeps its familiar rhythm. Jupiter glows where it usually glows. Orion returns each winter like an old neighbour who somehow never forgets your address. For long stretches of time, the cosmos gives the impression that nothing much changes at all. You can look up night after night and feel as though the universe is steady, patient, almost frozen. And then, every so often something happens. A star suddenly appears where there wasn't one before. An eclipse turns midday into twilight. A comet returns after generations have come and gone. An asteroid sweeps past Earth close enough that people step outside just to look at it with their own eyes. Entire crowds gather in silence under darkened skies, while the universe performs something that feels impossibly rare and strangely personal all at once. That is what tonight's journey is about. Not the distant future billions of years from now, when galaxies collide or the sun eventually swells into a red giant. Those events belong to timescales so enormous, they almost stop feeling real to us. No, tonight we're talking about rare cosmic events that living people, actual people, making tea and checking weather apps and forgetting where they left their glasses, may truly witness within a single human lifetime. And there is something deeply comforting about that. Because space is often described as cold, or indifferent, or unimaginably vast. And of course it is vast. But occasionally the universe does something unusually considerate for us. It puts on a spectacle within reach of human lives. It gives us events we do not have to imagine through fossils or equations alone. We get to stand beneath them directly. Some of the events we'll explore tonight are already approaching. Right now, as you listen, there is a star system quietly preparing for an eruption that may soon become visible to the naked eye. Somewhere above us, orbital paths are already aligning for eclipses and close encounters that astronomers have predicted decades in advance. Certain photons that will one day strike your eyes are already travelling toward Earth across enormous distances, heading patiently through darkness while humanity argues online about entirely unrelated things. That contrast has always been a little funny. The universe continues its enormous clockwork while down here someone is microwaving leftovers at 2 o'clock in the morning, wondering whether they replied to an email too aggressively. But before we wander farther into eclipses, comets, wandering asteroids, and exploding stars, I'd love to ask you something very simple tonight. Where are you listening from? And perhaps even more fitting for this particular topic, how old will you be when some of these events arrive? It's a curious thing to think about. A child listening tonight might still be alive to watch Halley's Comet return in 2061. Someone else may someday tell their grandchildren about standing beneath the long eclipse of 2027, or watching news coverage of Apophis gliding past Earth in 2029, while everyone collectively tried not to panic too dramatically. Human lives are usually measured through ordinary milestones: school years, birthdays, apartments, new jobs, old photographs, but occasionally they become bookmarked by the sky itself. People remember where they were during famous eclipses, during bright comets, during meteor storms, during lunar landings. Entire generations quietly carry these celestial memories with them for decades afterward. And if you find tonight's slow little voyage calming or interesting, or simply a pleasant companion for falling asleep, I'd be very grateful if you like the video and maybe subscribed as well. It helps this quiet corner of science reach other night owls, sleepy travellers, and people who accidentally opened a video about astrophysics at midnight thinking, well, I'll just listen for 5 minutes. which, historically speaking, is a dangerous sentence. Now then, let's settle in together for a while. Maybe you're listening under cloudy skies where the stars are hidden tonight. Maybe there's rain tapping against your window or streetlights glowing outside. Or perhaps you're somewhere far from cities where the night sky still stretches clearly overhead, crowded with stars humans have stared at for thousands upon thousands of years. Either way, above all of us, the universe is already moving toward its next performance. And the strange part is that most people rarely think about how unusual this moment in history really is. For almost all of human existence, the night sky changed very slowly. Ancient civilizations watched the planets wander through the constellations. They noticed eclipses. They recorded comets with fascination and fear. Sometimes a new star would suddenly appear in the heavens, shocking entire societies because the sky was believed to be eternal and unchanging. In the year 1054, for example, Chinese astronomers recorded a brilliant supernova so bright it could be seen during daylight. The explosion created what we now call the Crab Nebula. Imagine being alive then with no understanding of stellar physics, suddenly watching a new light appear in the sky where none had existed before. Entire cultures interpreted such events as omens, warnings, messages from gods, or signs that the order of the universe itself had shifted. Honestly, from their perspective, that reaction makes perfect sense. Even today, despite satellites and telescopes and modern astrophysics, there's still something unsettling about seeing the sky behave differently than expected. Humans grow attached to consistency overhead. We like believing the stars will remain where they belong, but space is not truly static. It only appears that way because human lives are short. Stars are born, stars die, asteroids drift, orbits shift, galaxies rotate, black holes collide, entire systems rearrange themselves over spans of time so enormous that our brains compress them into the illusion of permanence. The cosmos is moving constantly. We simply catch brief glimpses of its activity. And sometimes, if we happen to be alive at the right moment, we witness events rare enough that only a few generations ever see them firsthand. That idea has always given astronomy a slightly different emotional texture than other sciences. Chemistry happens in laboratories every day. Biology surrounds us continuously. Physics plays out in every thrown ball and every passing car. But astronomy often asks for patience, real patience. Sometimes astronomers wait decades for a comet to return. Sometimes they spend entire careers studying stars that may not significantly change within their lifetime at all. There are researchers who dedicate years to objects that won't fully reveal their secrets until long after they themselves are gone. Yet every now and then, the universe speeds things up for us. A nova flares unexpectedly. A comet brightens, an asteroid sweeps past Earth, an eclipse arrives exactly on schedule like a celestial train conductor who is impossibly punctual. And suddenly millions of people look upward together. That collective experience might be one of the rarest things of all nowadays. Humans do not often pause simultaneously anymore. Our attention is fragmented constantly. Different screens, different schedules, different worries, but rare astronomical events still have the ability to interrupt ordinary life for a moment. Schools stop classes for eclipses. Cities organize telescope gatherings. Families stand outside together in silence. Complete strangers share binoculars with each other. For a brief little stretch of time, humanity collectively remembers that we're all standing on the same planet under the same moving sky. That may be one reason cosmic events feel emotionally larger than they technically are. Take eclipses, for example. Scientifically speaking, an eclipse is just orbital geometry. The moon passes between Earth and the sun. Shadows align. Equations work exactly as predicted. Astronomers can calculate eclipses centuries into the future with extraordinary precision. And yet, when totality arrives, people cry. Not everyone, of course. Some people simply take photographs or whisper, "Wow," repeatedly, like malfunctioning robots programmed exclusively for amazement. But Many eclipse observers describe the experience as unexpectedly emotional. The air changes, birds grow quiet, shadows sharpen. The sky darkens in the middle of the day, while a black circle hangs overhead surrounded by the sun's glowing corona. Even knowing the science behind it does not remove the feeling. In some ways, the science makes it more impressive. You realise the moon is 400 times smaller than the sun, and also roughly 400 times closer to Earth, creating an almost absurdly precise coincidence that allows total eclipses to exist at all. The geometry is so exact it almost sounds invented, but it's real, and humans alive right now will soon witness one of the longest total solar eclipses of the century in 2027. That alone would have sounded extraordinary to people living hundreds of years ago. Then there are the objects that move through space quietly for ages before suddenly becoming headline news. Asteroids are particularly good at this. Most of the time they remain invisible to ordinary people, drifting through darkness without much public attention. But every once in a while one approaches Earth closely enough to trigger a very human combination of fascination and nervousness. Apophis is a good example. When astronomers first discovered it in 2004, early calculations briefly suggested a possibility of future impact with Earth. The odds were later ruled out entirely through improved observations, but for a little while humanity collectively experienced one of its favourite hobbies, catastrophizing enthusiastically. To be fair, a giant asteroid does sound alarming. But by 2029, Apophis will instead become something remarkable for a different reason. It will pass astonishingly close to Earth, closer than many satellites, visible to the naked eye from parts of the world. Not as a vague point of light requiring complicated equipment, but as a real moving object people may actually step outside and see crossing the sky. Think about how unusual that is. An object hundreds of meters wide silently gliding past our planet, while millions of humans watch from below holding snacks and checking astronomy apps. Space is strange. And then there are the returning visitors. Halley's Comet has been accompanying human history for longer than recorded civilization itself. Ancient astronomers observed it without understanding what it truly was. Medieval societies feared it. Artists painted it. Writers described it. Entire empires rose and fell between its appearances. The last time Halley's Comet visited the inner solar system was 1986. The next return will come in 2061. Some people listening tonight may still be here to see it. Others won't. There is something quietly emotional about that realization too. Astronomy constantly reminds us that we occupy only brief positions along much larger cycles. A comet returns whether individual humans survive to greet it or not. The universe keeps its schedule patiently across generations. Oddly enough, that can feel comforting instead of sad, perhaps because it places our lives inside something ongoing. And while many cosmic events unfold over impossible spans of time, a surprising number are approaching soon enough to feel personal. Not abstract future humanity, us, actual living people. That changes the emotional atmosphere entirely. You're not merely learning history tonight, you are listening to previews. Somewhere in the coming decades, school children not yet born will stand outside, looking upward during events astronomers are already discussing today. Somewhere a future elderly person will tell younger relatives, "I remember when scientists first announced this would happen." The future arrives gradually like that. Most people do not spend every night thinking about the universe. That probably sounds obvious, but it's worth sitting with for a moment. Human life is usually very close range. We think about tomorrow morning, about bills and groceries and weather forecasts, about text messages we forgot to answer 3 days ago but now feel too awkward to reply to. Our attention tends to stay near ground level because survival has always rewarded creatures that focus on immediate things. Find food, stay warm, avoid being eaten by something with too many teeth. For most of evolutionary history, staring dreamily into space for hours at a time was not especially productive behaviour, and yet humans kept doing it anyway. Even the earliest civilizations tracked the sky obsessively. Ancient people mapped stars before they fully mapped the earth beneath their feet. Long before modern science existed, humans were already recording eclipses, watching planetary movements, and telling stories about comets blazing across the darkness overhead. That says something important about us. There appears to be a deeply rooted human instinct that treats rare celestial events as meaningful in a way ordinary daily events are not. When something unusual happens in the sky, people pause, they gather, they remember it afterward for years, sometimes for the rest of their lives. And the curious thing is that this emotional reaction survives even after we understand the science. You might think scientific explanations would reduce the emotional impact of cosmic events. In theory, once you know an eclipse is simply orbital mechanics or that a comet follows predictable gravitational paths, perhaps the magic should disappear a little. But for most people, the opposite happens. Understanding the scale of these events often makes them feel even more personal and extraordinary. A total solar eclipse is more overwhelming once you realize how improbable the geometry truly is. Halley's Comet becomes more emotional once you understand that entire generations pass between appearances. A nova feels more startling when you learn that the sudden new star is actually a violent thermonuclear eruption happening across unimaginable distances. Knowledge does not erase wonder. Sometimes it sharpens it. And maybe that's because rare cosmic events create an unusual collision between two very different scales of existence. On one side, there is the universe itself, vast, ancient, indifferent to human schedules, stars exploding hundreds or thousands of light years away, giant rocks drifting silently through space, planetary orbits unfolding with mathematical precision, whether anyone notices them or not. On the other side, there is us, tiny humans standing outside in jackets, holding cups of tea and craning our necks upward, while trying not to trip over the garden furniture in the dark. That contrast should make these events feel emotionally distant, yet somehow they feel intensely close instead. Part of the reason may be timing. Human beings are deeply emotional about timing in general. We care enormously about being alive during particular moments. People often talk about historical timing with almost mystical significance. Imagine living during the construction of the pyramids, or during the age of dinosaurs, or during the first moon landing. Now think about astronomy specifically. Most celestial events unfold too slowly for humans to notice directly. Mountain ranges rise and erode across spans of time so immense they appear motionless. Stars live for billions of years. Galaxies rotate with patient slowness. Even continents drift so gradually that fingernails grow faster than tectonic plates move. Human lives are usually too short to witness major cosmic change firsthand. But rare events temporarily break that rule. Suddenly the universe does something visible within a single lifetime, something dynamic enough that you can point to a before and after. Before the nova, the star was invisible. Afterward, it shines clearly in the sky. Before totality, daylight surrounds you, then darkness falls at noon. Before the asteroid approaches Earth, it is just another distant object in astronomical databases. Then millions of people step outside together to watch it pass overhead. These moments create a strange feeling that the universe has briefly become active on human terms. Of course, that isn't really true. The cosmos is always active. Stars explode constantly across the universe. Black holes merge every day. Entire galaxies collide. But most of it happens either too far away, too slowly, or too invisibly for humans to emotionally connect with. Rare visible events shrink that emotional distance. They allow ordinary people to experience astronomy not as abstract information, but as something immediate and physical. And humans are deeply responsive to shared experiences. That might actually be one of the biggest reasons cosmic events feel so personal. Think about how humans normally encounter the sky today. Most people experience it privately or barely at all. Modern life has pulled much of humanity indoors beneath artificial light. Entire cities glow so brightly now that many children grow up never seeing the Milky Way clearly. In ancient history, the night sky was unavoidable. Now it competes with streaming services, yet rare astronomical events still manage to interrupt normal behaviour in ways very few things can. During major eclipses, entire highways fill with travellers, hotels book out years in advance, schools distribute eclipse glasses, news stations suddenly begin discussing orbital mechanics with varying degrees of success. People who normally never think about astronomy become temporarily fascinated by the exact position of the moon. There is something almost ancient about this behaviour. For a little while, humanity collectively looks upward again, and unlike many modern experiences, cosmic events are strangely democratic. The sky belongs to everyone simultaneously, rich or poor, scientist or cashier, child or retiree. Everyone under the right stretch of sky witnesses the same eclipse. That shared perspective matters emotionally. Humans evolved as communal creatures. We are affected profoundly by synchronized experiences, singing together, dancing together, mourning together, celebrating together. Even silence becomes emotionally powerful when shared by large groups. A total solar eclipse often creates exactly that kind of collective silence. People who witness totality frequently describe the crowd reaction afterward with unusual detail. The way conversations stop, the sudden drop in temperature, the instinctive gasps when the sun disappears, complete strangers hugging each other afterward as though they collectively survived something enormous. Scientifically, of course, nothing dangerous has occurred. Emotionally, though, something enormous has absolutely occurred. Humans have briefly felt themselves inside the machinery of the solar system, and that feeling can be surprisingly intense. Interestingly, psychologists have studied experiences like this using a concept called awe. Awe occurs when we encounter something so vast or complex that our normal mental frameworks struggle to contain it fully. The experience often creates a feeling of smallness combined with connection. That combination is important. Rare cosmic events make humans feel tiny, certainly. Standing beneath an eclipse or watching a comet streak overhead is an immediate reminder that we are very small creatures on a very small planet. But paradoxically, those same experiences can also make people feel more connected rather than less. Perhaps because everyone shares the same sky. Or perhaps because awe temporarily quiets many of the smaller concerns occupying the mind. When humans encounter something truly enormous, ordinary worries sometimes loosen their grip for a while. Deadlines and arguments and inboxes suddenly seem less central than they did 20 minutes earlier. Not permanently, unfortunately. Humanity always returns to arguing about parking eventually. Still, these moments matter. Astronauts describe something similar from orbit called the overview effect. Many astronauts report profound emotional changes after seeing Earth from space directly. National borders disappear visually. The atmosphere looks fragile. The planet appears both beautiful and vulnerable at the same time. Rare celestial events may create a smaller version of that feeling for people on Earth. For a brief moment, humans stop focusing exclusively on themselves and reconnect with a larger environment overhead. Even children sense this instinctively. If you've ever watched young children experience an eclipse, meteor shower, or bright comet for the first time, there's often a fascinating mix of excitement and confusion. Children are still forming assumptions about how stable the world is supposed to be. So when the sky suddenly behaves differently, they react honestly. Adults often try to appear composed. Children just point upward and yell things like, "The sun looks weird," which honestly is a perfectly reasonable scientific observation. Ancient humans likely reacted similarly before formal astronomy existed. Early civilizations treated unusual celestial events as powerful omens, partly because the sky appeared eternal and dependable. A sudden change overhead suggested that something fundamental had shifted in reality itself. And to be fair, if you had no modern astrophysics and witnessed a total eclipse unexpectedly, it would be terrifying. The sun disappearing in daytime is not subtle. Some ancient societies interpreted eclipses as dragons devouring the sun. Others believed the gods were angry, or that rulers had lost divine favour. Comets often triggered fear because they seemed unpredictable and disruptive compared to the orderly movement of stars and planets. What's fascinating is that even now, with modern science fully explaining these events, humans still react emotionally first and intellectually second. That tells us the emotional response runs very deep. There may also be another reason these events feel personal. Rare celestial phenomena remind humans of mortality in a strangely indirect way. Take Halley's Comet as an example again. For many people, Halley's return in 2061 will likely be the only opportunity they ever have to see it. The comet becomes not just an astronomical event, but a marker of an entire lifetime. People naturally calculate their age during future celestial events. I'll be 70 then. I wonder if I'll still be around for that one. My grandchildren might see it. Astronomy quietly forces humans to think in generational terms. That can feel sobering, but also meaningful. A person watching Halley's Comet in 2061 may remember relatives who saw it in 1986. Someone witnessing the eclipse of 2027 may someday describe it decades later to younger family members who weren't born yet. Cosmic events become woven into personal memory and family history simultaneously. And memory itself plays an important role here. Human beings remember unusual sky events exceptionally well because they activate multiple layers of perception at once. There is visual novelty, emotional intensity, social connection, and environmental change all happening together. Meteor showers create shared nighttime experiences, eclipses alter daylight itself, comets return after generations, novas introduce new stars into familiar constellations. These events violate normal expectations about how the sky behaves. The human brain pays very close attention to violated expectations. That's partly why people vividly remember where they were during famous astronomical events. The memory becomes anchored by contrast. An ordinary evening suddenly becomes historically unique. You went outside expecting normality. Instead, the universe did something memorable. And perhaps the most beautiful aspect of all this is that cosmic events do not care whether humans observe them. The eclipse will happen whether crowds gather or not. The nova will erupt whether anyone notices. Halley's Comet would return even if Earth were empty. There is something oddly comforting about that independence. The universe is not performing for us specifically, yet we're still invited to witness parts of it. Like arriving quietly at the edge of an enormous ongoing story. That may explain why astronomy often feels emotionally different from other sciences. Chemistry can feel controllable. Biology can feel immediate. But astronomy frequently creates the sensation that humans are participating in something far larger and older than themselves. Not controlling it, not directing it, just witnessing it together for a little while. And over the next several decades, humanity will receive an unusual number of opportunities to do exactly that. A star will briefly brighten, an eclipse will darken continents, asteroids will pass close enough to become visible to ordinary eyes, Mars will swell brighter in the sky than usual, a comet carried through history will return once more, and somewhere farther ahead, entire generations not yet born may gather beneath future skies watching events astronomers today can already predict with remarkable precision. The future sky is already scheduled, which is an astonishing thought when you really pause to consider it. At this very moment, the orbital paths responsible for future eclipses are already unfolding exactly as physics demands. Future comets are already travelling inward. Future alignments are already developing silently above us. The universe is preparing scenes humans have not yet witnessed, and among the very first of those approaching spectacles is one of the oldest and strangest astronomical phenomena humanity has ever recorded. Somewhere tonight above the northern hemisphere, hidden among ordinary-looking stars, there is a system quietly preparing for an explosion. not the kind that destroys a planet or tears apart a galaxy. This is something stranger than that, something both violent and temporary. A cosmic outburst that has happened before will happen again and may soon become visible to ordinary people simply standing outside beneath a dark sky. The system is called T Coronae Borealis, a name that sounds a little intimidating at first, though astronomers tend to enjoy naming things in ways that resemble either ancient spells or mildly complicated passwords. But despite the technical name, the story itself is surprisingly approachable. Because at its heart, T Coronae Borealis is really a story about build-up. Slow build-up. Patient build-up. The kind of build-up the universe seems especially fond of. And when the moment finally arrives, the result may be visible to millions of humans at once. A new star appearing where previously there was only darkness faint enough that most people never noticed it at all. That experience has happened before throughout human history. Ancient skywatchers occasionally looked upward and discovered stars where no stars had existed the night before. Some interpreted these sudden lights as omens, others saw them as signs from gods or warnings of major change. Without modern astrophysics, the idea of a new star appearing suddenly in the heavens was genuinely unsettling. Even today it still feels a little strange. We become emotionally attached to the stability of the night sky. Humans like believing the stars stay where they belong. So when something changes visibly overhead, even for scientific reasons we fully understand, there is still a tiny instinctive part of the brain that reacts with surprise. Now, technically, the star itself is not actually new. T Coronae Borealis has existed for a very long time, roughly 3,000 light-years away from Earth, in the constellation Coronae Borealis, the Northern Crown. Under normal conditions, it is far too faint for most people to notice without binoculars or telescopes. It simply sits quietly among countless other dim points of light, while humanity goes about its daily business completely unaware of it. But every so often, the system erupts, and for a short period it brightens dramatically enough to become visible with the naked eye. Astronomers call this type of event a recurrent nova. That word recurrent matters because unlike supernovas, which destroy stars completely, recurrent novas are repeat performers. The system survives the explosion and eventually builds toward another eruption later, which means T Coronae Borealis is not exploding for the first time. Humans observed major eruptions from this system in 1866 and again in 1946. During those events, the star brightened enormously within a short span of time before slowly fading once more into relative obscurity. And now, astronomers believe another eruption may happen soon, possibly very soon. There is something wonderfully unusual about living during a time when scientists can calmly announce that a star may suddenly appear brighter in the night sky sometime within the next year or so. Humanity has normalized astonishing information in a way that would completely bewilder earlier civilizations. Imagine explaining this casually to someone from the Middle Ages. Yes, that star over there might erupt temporarily, but don't worry, astronomers expected it. The conversation would probably become difficult after that. What makes T Coronae Borealis especially interesting is the mechanism behind the eruption, because this is not a single star behaving badly on its own. It is actually a binary system, meaning two stars orbit each other closely in a long-term gravitational relationship that is, frankly, a little unhealthy. One member of the pair is a white dwarf. White dwarfs are fascinating objects in general. They are essentially the dense leftover cores of stars that once resembled our Sun. After exhausting their fuel, such stars shed their outer layers and collapse inward, leaving behind an incredibly compact object packed with matter. A white dwarf can contain roughly the mass of the Sun compressed into a volume similar to Earth, which is difficult for human brains to picture properly. The material inside becomes so densely packed that ordinary concepts of matter start behaving strangely. A teaspoon of white dwarf material would weigh tons on Earth. Gravity near the surface becomes enormous. These objects are small, dim, and incredibly dense little stellar remnants quietly scattered throughout the galaxy. The other star in the T. Borealis system is a red giant. Red giants represent another stage of stellar aging. Stars like the Sun eventually expand dramatically as they exhaust hydrogen fuel in their cores. They swell outward, becoming cooler and redder while growing vastly larger than before. So now imagine this setup: a dense white dwarf orbiting very close to a bloated red giant. Already this sounds like the beginning of a complicated situation, and indeed it is. The white dwarf's gravity gradually pulls material away from the outer layers of the red giant, mostly hydrogen gas. This material spirals inward toward the white dwarf, collecting slowly over time on its surface like invisible cosmic snowfall. Year after year, decade after decade, more material accumulates. Pressure increases, temperature rises, and eventually conditions become extreme enough to trigger a thermonuclear runaway reaction across the surface. That reaction releases an enormous burst of energy. The system suddenly brightens dramatically, and from Earth, humans see what appears to be a new star lighting up the sky. The remarkable part is how quickly the change happens. Astronomical events often unfold frustratingly slowly from a human perspective. Galaxies rotate too gradually to notice directly. Mountains erode patiently. Stars evolve across millions or billions of years. But a nova can brighten within days. A seemingly ordinary patch of sky suddenly becomes different within the span of a normal human week. There is something emotionally powerful about that speed. It allows humans to feel like active witnesses rather than distant observers studying ancient history through telescopes. And unlike many astronomical phenomena requiring expensive equipment, this event may be visible without telescopes at all. Predictions suggest T. Borealis could become bright enough to see with the naked eye under dark skies. Not overwhelmingly bright. This will not outshine the moon or dominate the heavens dramatically like science fiction movies often suggest. But for attentive observers, a noticeable new point of light may appear in the northern crown, a star that was not visible before suddenly becoming easy to spot. Even now that sentence feels slightly unreal. What makes the anticipation especially interesting is that astronomers do not know the exact eruption date yet. They have observed changes in the system suggesting activity may be approaching, but predicting precise nova timing remains difficult. So humanity is currently in a strange waiting period. Astronomers continue monitoring the system carefully, while ordinary sky watchers occasionally glance upward, wondering whether tonight might be the night the star brightens. There is something charmingly human about this kind of anticipation. People have always waited for the sky to do things. Ancient civilizations waited for eclipses and seasonal stars. Sailors watched for certain constellations to guide navigation. Farmers tracked celestial cycles for planting and harvests. Modern astronomers monitor distant systems through telescopes and spectrographs, waiting for signals that major changes are beginning. Humanity has always been a species that watches, and T. Borealis gives modern humans a rare chance to participate emotionally in that ancient tradition again, not passively reading about some event after it happened centuries ago. Waiting together in real time, the waiting itself becomes part of the experience. You could argue that anticipation adds emotional weight to rare cosmic events in general. Humans become attached not only to the event itself, but to the knowledge that it is approaching. Think about eclipses. People plan trips years in advance. Hotels fill. Maps circulate online. Entire communities prepare together. The same thing is happening here on a smaller but still meaningful scale. Astronomy groups discuss visibility conditions. People learn where Corona Borealis sits in the sky. Others quietly hope the eruption happens during clear weather where they live because clouds, unfortunately, remain one of astronomy's greatest enemies. The universe can arrange thermonuclear stellar eruptions perfectly, and Earth will still occasionally respond with, "Best I can do is rain." Astronomy has always involved patience mixed with mild frustration. But even if someone misses the exact moment the nova brightens, the event should remain visible for days or possibly longer depending on brightness and observing conditions. This is not a split-second phenomenon. The star will gradually brighten and then slowly fade over time. And somewhere during that interval, millions of people may step outside and look upward at something human beings have witnessed only a handful of times from this particular system. That thought connects generations in a surprisingly intimate way. Someone alive in 1946 may have seen the previous eruption as a child. A person witnessing the next eruption might someday describe it decades later to grandchildren or friends. I remember when that star suddenly appeared. Astronomy creates memories like that, not because the events change daily life dramatically, but because they briefly interrupt the normal expectation that the sky remains fixed and permanent. And permanence is something humans crave, perhaps because human lives themselves feel so temporary. There is comfort in the stars behaving consistently overhead year after year. Constellations return seasonally. Familiar planets rise and set predictably. The night sky becomes part of the emotional architecture of life. So when a visible change occurs, even a temporary one, humans notice deeply. That emotional reaction likely reaches back very far into history. The ancient Chinese carefully recorded guest stars, sudden bright objects appearing unexpectedly in the heavens. Medieval astronomers documented novas and supernovas with fascination. Tycho Brahe famously observed a supernova in 1572 that challenged existing beliefs about the unchanging perfection of the heavens. Because if the sky could change, then perhaps the universe itself was more dynamic than people assumed. Today we know the universe is dynamic almost beyond comprehension. Stars are constantly forming and dying across the galaxy. The Milky Way alone contains hundreds of billions of stars. Somewhere every night there are collisions, eruptions, bursts of radiation, and gravitational chaos unfolding invisibly. Yet humans still react emotionally when one tiny fraction of that activity becomes directly visible. Maybe because visibility matters psychologically. There is a profound difference between intellectually knowing stars explode somewhere versus personally walking outside and seeing an unfamiliar light in the sky. The first is information. The second becomes experience, and experiences stay with people. Years from now, someone may remember exactly where they were when they first spotted the nova, perhaps standing in a backyard after checking astronomy news updates, perhaps driving home late at night and noticing something unusual overhead, perhaps being awakened excitedly by a family member insisting, "Come outside right now." Those little human details matter. Science sometimes gets described as cold or impersonal, but astronomy repeatedly becomes emotional once actual people encounter these events directly. The data matters, certainly. Spectroscopy and measurements and orbital calculations matter enormously. But so do the quiet moments where ordinary humans simply stand beneath the sky feeling connected to something larger. And T. Coronea Borealis is particularly good at creating that feeling because the event itself is both accessible and temporary. Temporary things often affect humans more strongly. Cherry blossoms bloom briefly. Childhood passes quickly. Comets disappear for generations. A nova brightens and fades. Part of the emotional impact comes precisely from knowing the event will not last forever. Eventually T. Coronea Borealis will dim again, the eruption will end, the star will retreat back into faint obscurity visible only through telescopes. Life on Earth will continue normally, but for a short while the sky will look different, and somewhere, perhaps. On a cool quiet evening not very far from now, a person will glance upward and realise they are looking directly at a thermonuclear eruption occurring 3,000 light-years away. Which is a truly absurd sentence when you stop to think about it. Humans evolved to throw rocks and avoid predators, Yet here we are discussing stellar explosions visible across thousands of light years while sitting comfortably indoors with electric lighting and internet connections. Civilization became very strange very quickly. There are very few moments in modern life when large groups of people willingly stop everything at the exact same time just to look upward. Not at phones, not at stadium screens, not at fireworks, at the sky itself. A total solar eclipse still has that power, and perhaps that should not be surprising. For most of human history, the sun was the single most dependable object in existence. It rose, it crossed the sky, it warmed crops and guided travel and marked the rhythm of entire civilizations. Human beings built religions and calendars around its reliability. Then occasionally, without warning in ancient times, it vanished. Even now, with all our astronomy and equations and orbital models, there remains something deeply unsettling about seeing daylight suddenly behave incorrectly. Because that is exactly what a total eclipse feels like. Incorrect. Not dangerous, not supernatural, not catastrophic, but wrong, in a way that reaches somewhere deeper than logic. The brain understands perfectly well what is happening. The moon passes between Earth and the sun, shadows align, physics proceeds normally, and yet every instinct still whispers that midday should not look like twilight. That strange emotional contradiction is one reason eclipse chasers exist at all. Yes, eclipse chasers are real people, entire communities of them. Humans who travel enormous distances across oceans, deserts, mountains, and continents, pursuing a few fleeting minutes of darkness beneath the moon's shadow. Some people collect stamps, others willingly cross the planet for orbital geometry. Honestly, both hobbies sound slightly odd when phrased correctly, but eclipse chasing becomes easier to understand once you realize that totality, the period when the sun is fully covered, does not feel remotely similar to a partial eclipse. People who have never experienced totality often assume it's simply a darker version of daytime. It is not. The difference between a partial eclipse and totality is often compared to the difference between almost being asleep and actually dreaming. One gradually approaches the experience, the other suddenly transforms reality itself. And in August of 2027, millions of people may witness one of the most extraordinary examples of totality in the modern era. Astronomers are already calling it one of the longest and most spectacular total solar eclipses of the 21st century. That alone is enough to make eclipse enthusiasts start checking flight prices nervously. The eclipse of August 2nd, 2027 will sweep across parts of Europe, North Africa, and the Middle East. Locations along the center of the eclipse path may experience more than 6 minutes of totality. 6 minutes may not sound especially long at first. Human beings waste 6 minutes every day trying to decide what to watch while already holding the remote. But during totality, 6 minutes feels enormous. Many total solar eclipses provide only 2 or 3 minutes of complete darkness. Some last barely longer than a song on the radio. Eclipse chasers often describe totality as emotionally overwhelming precisely because it ends so quickly. People wait years or decades for an event that disappears almost immediately. The 2027 eclipse, however, offers unusually long darkness by eclipse standards. And to understand why that matters so much, it helps to first understand what totality actually feels like in person. Because photographs never quite capture it properly. Modern cameras can produce beautiful eclipse images, certainly. Sharp coronas glowing around black solar disks, pink prominences curling outward from the sun, darkened horizons stretching beneath twilight skies. But photographs flatten the emotional experience dramatically. The real event feels physical. The process begins gradually enough. At first, the sun simply develops a small missing piece along one edge as the moon slowly moves across it. Daylight remains mostly normal. Casual observers may glance up through eclipse glasses occasionally and think, well, that's interesting. Then more sunlight disappears, shadows sharpen strangely. The air begins cooling. Animals sometimes start reacting before humans fully notice the environmental shift. Birds quiet down. Insects change behaviour. Some animals prepare for nighttime because their instincts interpret the darkening sky literally. Humans become quieter too. That part is fascinating. Crowds watching eclipses often begin noisy and social. People chat, compare equipment, adjust cameras, make jokes. Then as totality approaches, conversations fade gradually. Anticipation takes over. The light becomes increasingly strange. Not simply dimmer, but thinner somehow. Colours flatten. The landscape develops an eerie metallic quality, unlike ordinary sunset lighting. Experienced eclipse observers often say the world begins looking emotionally unfamiliar before totality even arrives. And then the last thin crescent of sunlight disappears. Suddenly the corona erupts around the black disk of the moon. Stars become visible. The horizon glows in every direction like distant sunset. And the human brain immediately realizes this is not normal darkness. Nighttime arrives differently. Normal night falls gradually. Totality drops like a curtain. People gasp. They always gasp. Even scientists who fully understand the mechanics behind eclipses often react emotionally during totality. Astronomers who have spent entire careers studying celestial motion still sometimes cry beneath the moon's shadow. That says something important about the experience. The emotional impact survives explanation completely intact. Perhaps because humans are not emotionally designed for sudden midday darkness. Our species evolved under extraordinarily stable solar conditions. The sun disappearing abruptly triggers something ancient and instinctive deep inside the nervous system. But alongside that instinctive unease comes awe. Enormous awe. The corona itself contributes heavily to that feeling. Normally the sun's outer atmosphere is invisible, because ordinary sunlight overwhelms it completely. During totality, however, the corona becomes visible as delicate glowing structures extending outward around the moon. It looks unreal. Not unreal in the sense of fake, but unreal in the sense that the human brain struggles briefly to categorize what it is seeing. The sky no longer resembles ordinary experience. It becomes something sharper, stranger, almost theatrical, and yet entirely natural. That combination is powerful psychologically. Humans respond intensely to natural phenomena that feel larger than ordinary life while still remaining visibly real. Thunderstorms, volcanoes, auroras, eclipses, events that remind us Earth exists inside larger systems beyond human control. A total eclipse may be one of the clearest examples of that feeling available without leaving the planet entirely. What makes the 2027 eclipse especially extraordinary is the geometry involved. Total solar eclipses only happen because of an astonishing coincidence. The sun is roughly 400 times wider than the moon, but also about 400 times farther away. As a result, both objects appear almost exactly the same size in Earth's sky. That coincidence allows the moon to cover the sun with eerie precision. And it truly is a coincidence. The moon is gradually drifting away from Earth over long timescales at a rate of roughly 3.8 centimeters per year. Hundreds of millions of years from now, total solar eclipses may no longer occur because the moon will appear too small to completely cover the sun. Which means humanity happens to exist during a geological period when total eclipses are possible. That realization alone makes eclipses feel strangely personal. Not only are they rare within individual lifetimes, they're also temporary features of Earth's long history itself. Dinosaurs experienced eclipses. Future distant Earth may not. And in August 2027, one of the finest examples available to modern humans will unfold across parts of the world where millions may gather beneath the shadow path. North Africa is expected to host some of the longest durations of totality. Egypt in particular may experience over 6 minutes of darkness in certain regions. That is an extraordinarily long time in eclipse terms, long enough for the emotional rhythm of totality to change. Short eclipses often feel frantic. People try desperately to absorb the experience before it vanishes. Cameras click wildly. Observers panic slightly about wasting precious seconds. Longer totality allows something different to happen. People settle into the darkness. The event becomes less like a sudden shock and more like temporarily existing inside another version of daytime entirely. Experienced eclipse chasers often describe a curious emotional transition during long totality. At first, there is astonishment and adrenaline. Then, after a minute or two, the brain begins adapting slightly to the impossible environment. Humans start looking around more calmly. They notice details in the landscape: wind, temperature, horizon colours, planetary visibility. Reality rearranges itself temporarily. Then, just as the mind begins accepting the strange conditions, sunlight returns explosively. That sudden return can feel emotional too. A brilliant point of sunlight bursts outward from the moon's edge, creating what astronomers call the diamond ring effect. Daylight floods back rapidly. Birds react again. Crowds erupt into applause or cheering or stunned silence. And afterward, many people experience something surprisingly close to grief. That may sound dramatic, but eclipse chasers talk about this often. Totality ends so abruptly that people feel genuine sadness when ordinary daylight returns. Not because daylight is unpleasant exactly, but because the experience was so unusual and so temporary. Humans become emotionally attached to rare moments very quickly. Maybe because life itself is built from temporary things. What's interesting historically is that eclipses once inspired almost pure fear in many cultures. Ancient societies interpreted them as signs of divine anger, cosmic imbalance, or approaching disaster. Some civilizations beat drums or made loud noises during eclipses, attempting to save the sun from whatever force appeared to be devouring it. Again, from their perspective, that reaction makes complete sense. Imagine seeing totality unexpectedly with no scientific understanding whatsoever. The temperature drops, animals panic, stars appear in daytime, the sun vanishes. Modern humans, fortunately, possess astronomy, though admittedly some people still react to eclipses online, as if the universe personally scheduled the event to inconvenience traffic patterns. Humanity remains wonderfully consistent. Yet despite scientific understanding replacing superstition, eclipses continue producing a kind of emotional humility that is difficult to replicate elsewhere. Partly because eclipses are visible proof that humans live inside a moving celestial system. We often think of ourselves as stationary creatures standing on solid ground beneath a stable sky. Totality disrupts that illusion dramatically. The eclipse reveals motion directly. The moon is moving. Earth is moving. Everything is moving. And for a few minutes, humans become intensely aware of that fact in a physical rather than intellectual way. That awareness affects memory strongly too. People tend to remember eclipses with unusual vividness. The emotional intensity, environmental changes and rarity combine into powerful long-term memories. Someone who witnesses the 2027 eclipse may still recall tiny sensory details decades later. The exact quality of the wind, the crowd noise, the strange twilight colours, the feeling of looking upward during complete totality for the first time. Astronomy creates memories differently than ordinary daily life because cosmic events arrive with built-in rarity. Humans instinctively assign importance to experiences unlikely to repeat soon, and the eclipse of 2027 belongs very much to that category. Some people listening tonight may already be planning where they hope to see it. Others may encounter it unexpectedly through news coverage or family travel or simple curiosity. Children alive today may someday describe it as one of their clearest childhood memories. That is another beautiful thing about eclipses. They become generational landmarks. People remember where they were during famous eclipses, much like older generations remember historical world events. Entire families often experience them together outdoors. Parents hand eclipse glasses to children. Grandparents explain older eclipses they once witnessed decades earlier. For a little while, everyone shares the same shadow, and after the moon finally moves onward and ordinary daylight returns fully, humanity will continue its patient orbit around the sun exactly as before. But the emotional afterglow lingers, perhaps because eclipses temporarily expose how delicate our normal reality actually is. Daylight depends entirely on geometry, seasons depend on tilt, stability depends on orbital relationships unfolding precisely over immense stretches of time. The universe is reliable, yes, but it is also dynamic. Human beings have a very complicated emotional relationship with asteroids. On one hand, we know scientifically that most asteroids are harmless. Space is enormous, Earth is relatively small, and the solar system is mostly empty in the same way an enormous desert is mostly empty, except with fewer convenient gas stations. Millions of rocks drift through space without bothering anyone at all. On the other hand, humanity is also fully aware that one asteroid impact helped end the age of dinosaurs. Once you learn that fact as a child, it tends to stay with you forever. Dinosaurs ruled Earth for more than 160 million years. Then one extremely unfortunate day, a large space rock arrived uninvited and permanently changed the planet's history. That story settles somewhere deep in the human imagination, because it combines two things our brains find especially unsettling: randomness and scale. The dinosaurs were not defeated gradually by some rival species plotting against them. They were simply living their enormous dinosaur lives when the cosmos abruptly intervened with catastrophic enthusiasm. Ever since modern science confirmed that history, asteroids have occupied a strange place in popular culture. They are simultaneously scientific objects and psychological symbols. Whenever people hear about a close asteroid approach, imagination tends to sprint several miles ahead of reality immediately. News headlines do not always help. Humanity has a long tradition of encountering interesting astronomical information and responding with the emotional stability of caffeinated squirrels. Which brings us to Apophis. Even the name sounds dramatic. That was probably unavoidable because the asteroid was named after Apep, the ancient Egyptian serpent deity associated with chaos and darkness. Astronomers occasionally enjoy giving space objects names that sound like they belong in apocalyptic movie trailers. Technically, Apophis is asteroid 99,942 Apophis, discovered in 2004 by astronomers Roy Tucker, David Tholen, and Fabrizio Bernardi. It measures roughly 340 meters across, making it large enough to command serious scientific attention, but nowhere near large enough to threaten extinction-level destruction on a dinosaur scale. Still, 340 meters is not small. A structure that size passing near Earth naturally attracts interest. And shortly after its discovery, Apophis became briefly famous for a rather uncomfortable reason. Early orbital calculations suggested a small but non-zero chance that the asteroid might impact Earth in 2029. Now, to astronomers, this was a perfectly normal stage in the process of refining orbital predictions. Newly discovered asteroids initially come with uncertainties because scientists are working from limited observational data. As more observations accumulate, the orbit becomes increasingly precise. But to the general public, the phrase "asteroid might hit Earth" tends to overshadow the quieter phrase "early calculations still uncertain." Human brains are selective like that. For a brief period, Apophis received enormous attention because the estimated impact probability, while still small, was unusually high compared to most newly discovered near-Earth asteroids. Scientists quickly continued tracking the object, improving measurements and refining models. Eventually, the feared impact scenario was ruled out entirely. Then later, potential future impacts were ruled out too. Today, astronomers are extremely confident Apophis will not collide with Earth in 2029 or in the foreseeable future afterward. Instead, something arguably more fascinating will happen. It will, pass astonishingly close to Earth. Very close. Close enough to become visible to the naked eye from parts of the planet. Close enough to pass nearer than many communication satellites orbiting Earth. Close enough that humanity may actually watch a mountain-sized asteroid move across the night sky in real time. That sentence still sounds like science fiction, and perhaps the strangest emotional aspect of the whole event is not panic or danger, but calm. A strange calm. Because by 2029, humanity will likely spend months discussing an enormous asteroid gliding safely past Earth with a mixture of excitement, fascination, and surprisingly casual conversation. Are you watching the asteroid tonight? Yes, right after dinner. That is such an absurdly modern exchange. For almost all of human history, objects appearing unexpectedly in the sky inspired fear. Comets, eclipses, novas, meteor storms. Anything unusual overhead often triggered anxiety because ancient people lacked the scientific tools to predict celestial motion accurately. Modern astronomy changed that relationship completely. Now, humans can calculate asteroid trajectories decades into the future with astonishing precision. We know where Apophis will be years before the event itself. Scientists can model its motion, gravitational interactions, and close-approach geometry in remarkable detail. The fear has largely been replaced by anticipation, and anticipation changes everything emotionally, because instead of feeling like helpless witnesses beneath unpredictable skies, humans now experience many cosmic events as informed participants. We know the asteroid is coming, we know when it will arrive, we know roughly where to look. There is something deeply comforting about that transformation. Science did not remove the wonder from the sky, it removed the helplessness. Still, even knowing Apophis poses no danger, the numbers involved remain extraordinary. At closest approach on April 13th, 2029, Apophis will pass within roughly 32,000 kilometers of Earth's surface. In astronomical terms, that is incredibly close. The Moon, by comparison, orbits at an average distance of about 384,000 kilometers. Apophis will pass roughly 10 times closer than the Moon. Some satellites orbit farther away than Apophis will, and unlike many asteroids visible only through telescopes, this one should become bright enough for ordinary observers to see with the naked eye under favourable conditions. Not as a giant looming object dominating the sky, of course. Hollywood continues misleading people about asteroid appearances quite dramatically. Even a relatively close asteroid still appears star-like to human vision. But it will move visibly against the background stars over time. A real asteroid, moving, across the sky above Earth. Imagine ancient humans hearing that sentence. Actually, imagine most modern humans hearing that sentence without context. Many would probably assume scientists were about to begin yelling urgently, while dramatic orchestral music intensified in the background. Instead, astronomers are mostly excited, because close asteroid encounters like this are scientifically valuable opportunities. Apophis will allow researchers to study how Earth's gravity affects a sizable asteroid during close passage. Some scientists believe tidal forces may slightly alter the asteroid's rotation or surface structure. Loose material on Apophis could shift. Tiny asteroid quakes may occur as Earth's gravity interacts with the object during flyby. That concept alone is wonderful. An asteroid passing close enough for Earth's gravity to physically reshape it slightly, while millions of humans observe from below. The universe occasionally becomes cinematic entirely on its own, and unlike distant astronomical events requiring imagination across huge scales, Apophis feels unusually immediate. Asteroids occupy the same solar system neighborhood as Earth. They are not abstract galaxies billions of light years away. They are nearby objects sharing our orbital environment. That closeness affects human psychology strongly. Space often feels emotionally distant because most celestial objects are unimaginably far away. But asteroids crossing near Earth temporarily shrink the perceived size of the solar system. They remind humans that Earth exists inside a busy, gravitational ecosystem filled with wandering objects, some harmless, some potentially dangerous, most simply drifting silently through space. There is also something fascinating about the date itself. Friday, April the 13th, 2029. Yes, Friday the 13th. Humanity truly enjoys adding extra drama whenever possible. Conspiracy theories surrounding Apophis will almost certainly flourish, despite scientific clarity about the asteroid's safety. This happens regularly with astronomical events. Even eclipses still generate strange predictions online despite centuries of successful eclipse forecasting. The internet remains one of humanity's most creative storytelling systems. But beneath the inevitable sensationalism lies something genuinely meaningful about the Apophis flyby. It may become one of the first major asteroid encounters experienced collectively by a globally connected civilization. That distinction matters. Previous generations lacked modern communication networks. An unusual celestial event might take weeks or months to spread through societies historically. In 2029, billions of people may follow the flyby simultaneously through live streams, observatories, astronomy apps, social media, and personal observation. Children may watch it from apartment balconies. Amateur astronomers will set up telescopes in parks. Professional observatories will track every detail carefully. And millions of ordinary people who normally never think about asteroids will suddenly become interested in orbital mechanics for one evening. Rare cosmic events do that repeatedly. They interrupt routine attention patterns. Humans spend much of life focused downward toward immediate concerns. Celestial spectacles briefly redirect collective awareness upward again. Apophis is especially interesting because it combines awe with reassurance. The asteroid is large enough to feel impressive, close enough to feel real, but safe enough to enjoy peacefully. That emotional balance creates an unusual atmosphere. People can experience the thrill of proximity to cosmic danger without actual danger itself. A kind of safe confrontation with planetary vulnerability. And planetary vulnerability is something humanity increasingly thinks about nowadays. For most of history, humans viewed Earth as essentially permanent and secure. Modern science complicated that assumption considerably. We now understand Earth exists within larger systems capable of disruption. Climate shifts, solar activity, asteroid impacts, supervolcanoes, cosmic radiation. The planet is not isolated from the universe, it is immersed within it. Apophis becomes emotionally powerful, partly because it makes that immersion visible. Earth and asteroid crossing paths dramatically within a shared gravitational dance. Yet instead of inspiring despair, events like this often produce the opposite reaction. Humans respond to awe-inspiring natural phenomena with curiosity and togetherness surprisingly often. Perhaps because collective observation reduces fear. Looking upward together changes the emotional texture of uncertainty. And humans have always watched the skies collectively during unusual events. Ancient cultures gathered during eclipses. Medieval societies tracked comets. Early astronomers documented meteor storms and planetary alignments with careful attention. Modern humanity continues the same tradition through different technology. Only now we live stream the asteroid instead of carving records onto stone tablets. Civilization evolves in interesting ways. There is another emotional layer to Apophis as well. Timing. By 2029, children currently in elementary school may clearly remember the event for the rest of their lives. Adults listening tonight may calculate automatically where they expect to be in April 2029. I'll be living somewhere else by then. My kids will be older. I wonder what the world will look like. Rare future astronomical events quietly encourage humans to imagine themselves inside the future. Not abstract future history, but personal future memory. That is psychologically important. The future often feels vague and difficult for humans to picture emotionally, but scheduled celestial events create fixed points ahead in time. They become future landmarks already waiting for us. Somewhere ahead exists a night when Apophis will pass overhead. The universe has already scheduled it. All Earth has to do is continue arriving there. That perspective can feel strangely comforting during uncertain times. Governments change, technologies shift, entire societies transform rapidly. Yet orbital mechanics continue patiently through it all. The asteroid does not care about politics. Gravity remains wonderfully uninterested in social media arguments. Perhaps that stability is part of why astronomy feels calming for so many people. Celestial motion unfolds according to reliable principles larger than individual human chaos. And although Apophis itself will pass safely onward after 2029, the flyby may significantly improve humanity's planetary defense capabilities too. Yes, planetary defense is a real scientific field now. Again, ancient humans would be astonished by modern conversations. Scientists actively monitor near-Earth objects and develop methods for potential asteroid deflection if future threats emerge. NASA's DART mission already demonstrated the ability to alter an asteroid's trajectory slightly by crashing a spacecraft into it intentionally. Humanity has officially entered the era of experimentally nudging space rocks, which feels both impressive and slightly concerning somehow. Still, Apophis itself requires no intervention. The asteroid will pass harmlessly, providing science, spectacle, and perhaps a subtle reminder that Earth occupies a dynamic cosmic environment rather than a perfectly isolated sanctuary. There is something deeply unsettling about the phrase "almost hit." Human beings are strangely emotional about near misses, sometimes more emotional than actual events themselves. A glass falling toward the floor but somehow not breaking. A car narrowly avoiding collision. A missed step on a staircase that sends a pulse of adrenaline through the body before relief arrives half a second later. The human nervous system reacts powerfully to the realization that reality could have unfolded differently. And in the year 2032, humanity may witness a very unusual cosmic version of that feeling. An asteroid known as 2024 YR4 is expected to pass extraordinarily close to the Moon. Not Earth. The Moon. And while current predictions indicate the asteroid will likely miss entirely, the event is still remarkable because it places something emotionally familiar, the Moon itself, inside a visible moment of cosmic vulnerability. That changes the atmosphere considerably. Human beings are emotionally attached to the Moon in ways difficult to fully explain. It is more than just another astronomical object. The Moon feels personal. It has accompanied humanity for all of recorded history. Ancient people tracked months by its phases. Sailors navigated beneath it. Poets wrote about it endlessly with varying degrees of success. Lovers stood beneath it dramatically. Wolves received an unfair amount of fictional responsibility involving it. The Moon became woven into human culture so thoroughly that it almost feels less like an object and more like part of Earth itself. Which, scientifically speaking, it essentially is. The Moon formed billions of years ago after a colossal collision between the young Earth and another large body sometimes called Theia. Debris from that ancient impact eventually coalesced into the Moon we know today. In other words, the Moon is literally connected to Earth's violent history from the beginning, and ever since then it has remained astonishingly important to life on this planet. The Moon stabilizes Earth's axial tilt, influences tides, affects ecosystems, shapes biological rhythms, and illuminates the night sky with enough brightness that entire species evolved around lunar cycles. Human civilization itself developed beneath regular moonlight for thousands upon thousands of years before electric lighting existed. For most of history, the Moon was humanity's nighttime companion, reliable, predictable, permanent. So when astronomers discuss an asteroid passing unusually close to it, people react emotionally, almost instinctively. Not because the Moon is truly in danger of destruction. The Moon has survived billions of years of bombardment already. Its cratered surface is essentially a historical archive of ancient impacts. But humans do not usually think about the Moon that way emotionally. We think of it as stable, comforting, familiar overhead scenery. That familiarity matters, and 2024 YR4 introduces an unusual psychological twist because it creates the image of an asteroid nearly interacting with one of humanity's most emotionally recognizable celestial neighbors. Now, technically speaking, the event itself may not become visually dramatic to ordinary observers. There will likely be no giant explosion visible from Earth or catastrophic lunar damage. The asteroid is expected to miss. But the closeness alone is scientifically fascinating and emotionally revealing. Because events like this remind humans that the solar system is not static or perfectly orderly. Objects constantly move through shared gravitational space. Asteroids pass planets. Meteoroids strike moons. Comets wander inward from distant reservoirs of ice and dust. The cosmos is busy. We simply experience most of that activity across timescales too large or distances too vast to notice personally. Near misses compress those realities into something emotionally immediate, and humans pay close attention to immediacy. The asteroid itself, 2024 YR4, entered scientific awareness only recently. Modern asteroid surveys continuously scan the skies searching for near-Earth objects and tracking their trajectories with improving precision every year. Thousands upon thousands of objects are catalogued this way, most completely harmless. Occasionally, however, one stands out due to unusual orbital geometry or a particularly close future approach. That is how certain asteroids briefly become famous. Though famous may not be quite the right word, rocks generally handle celebrity poorly. What makes 2024 YR4 especially interesting is not merely its path, but the emotional framing surrounding lunar proximity. Humans already understand Earth can experience impacts. History and geology make that abundantly clear. But seeing another object pass extremely close to the Moon creates a slightly different emotional response. Perhaps because humans psychologically treat the Moon almost like part of our shared home environment, rather than outer space proper. And honestly, that feeling makes sense. The Moon is close. Very close, astronomically speaking. It takes light only about 1.3 seconds to travel from the Moon to Earth. Apollo astronauts reached it within days. Human beings have physically walked there. The Moon dominates our night sky visually in a way no other celestial object besides the Sun can match. People notice when something interacts with it. Imagine standing outside one evening in 2032, knowing that somewhere near that bright familiar object, a sizable asteroid is silently gliding past through darkness. The Moon itself will likely remain unchanged visually. The asteroid may not even be visible to most people without equipment, yet the knowledge alone alters perception slightly. Suddenly the Moon feels less isolated, less untouchable, part of a moving system rather than a permanent decoration hanging safely overhead. Astronomy repeatedly produces this effect. It transforms familiar objects into dynamic participants within larger cosmic processes. The Sun becomes a nuclear furnace. The stars become distant suns. The Moon becomes a world. And near misses become reminders that celestial motion never truly stops. Interestingly, the human brain often struggles emotionally with probabilities and scales in situations like this. People tend to categorize outcomes too simply. Hit, miss, safe, dangerous. Reality is usually more nuanced. Near misses in astronomy involve extraordinary precision already. Space is enormous, yes, but orbital mechanics are incredibly exact. Tiny changes in speed or position over long periods can alter trajectories dramatically. Gravitational interactions between planets, moons, asteroids, and even subtle effects like sunlight pressure gradually shape orbital paths over time. The solar system resembles an immense gravitational choreography unfolding continuously. Most of the time it works beautifully. Occasionally objects come very close, and humans notice those moments because they expose the delicate balance underneath ordinary celestial stability. The Moon itself bears countless scars from past impacts. Without atmosphere or weather to erase craters efficiently, its surface preserves billions of years of collision history. Every visible crater represents an event once violent enough to reshape lunar terrain permanently. When humans gaze at the full moon, they are looking directly at accumulated evidence of cosmic impacts. That thought changes moonlight slightly, doesn't it? The familiar grey patterns visible from Earth are partly geological memories of ancient collisions, yet despite all those impacts, the moon persists calmly overhead, stable enough that humans built calendars around it, stable enough that lovers write songs about it instead of worrying about orbital bombardment. The emotional contradiction there is very human. We coexist with cosmic violence constantly, while emotionally editing most of it into background normality. Earth does this too, of course. Our planet experiences small meteoroid impacts continuously. Tiny particles strike the atmosphere every day, producing brief meteors or shooting stars. Larger impacts happen far more rarely, but the solar system remains active. The atmosphere protects Earth remarkably well. The moon lacks that protection entirely, which is why lunar impacts occur visibly sometimes even today. Astronomers occasionally observe brief flashes on the moon caused by meteoroids striking its surface. Small impacts happen in real time while humans watch from Earth. Again, the universe is busier than it appears, and perhaps that constant hidden activity contributes to why near misses fascinate people so strongly. They briefly expose the underlying dynamism normally hidden beneath the illusion of celestial permanence. There is also something emotionally unique about events involving the moon specifically because humans project familiarity onto it so easily. No other celestial object besides the sun occupies such a large role in ordinary human experience. People casually notice the moon while walking home or driving or taking out the trash. Children recognize it early in life. Entire cultures built myths around it independently. The moon belongs psychologically to everyone, so any event associated with it automatically feels personal on some level. Even now, long before 2032 arrives, people reading about future lunar near misses instinctively visualize the moon first. Not orbital diagrams or gravitational calculations. The moon itself, bright overhead, familiar. That emotional familiarity may also explain why lunar exploration resonates so strongly compared to many robotic missions deeper into space. Humans emotionally connect with the moon because it remains visibly present in daily life. Mars feels distant. Europa feels abstract. The moon watches quietly from outside your window, and in 2032, millions of people may look upward at it while thinking about something invisible passing nearby through darkness. That invisible aspect matters too. Astronomy often asks humans to emotionally engage with things they cannot directly see. Black holes, exoplanets, dark matter, gravitational waves. Much of modern astrophysics involves phenomena detected indirectly through measurements and inference. Yet humans still become emotionally invested. Perhaps because imagination fills gaps naturally. Knowing an asteroid is passing near the moon changes the emotional atmosphere of the night sky, even if nothing visually dramatic occurs. It transforms ordinary moonlight into part of an ongoing celestial event. And rare events reshape memory. That continues happening throughout every cosmic spectacle humans experience collectively. Eclipses, comets, novas, meteor storms, near-asteroid flybys, each becomes attached to personal timelines. People remember where they were, who they were with, how the sky looked, what the air felt like. Astronomy creates sensory memory unusually well, because it combines rarity with physical environment. Humans are not merely learning facts during these moments. They are physically existing beneath the event itself. The body remembers that. And perhaps the most fascinating thing about near misses psychologically is that they remind humans how narrow stability sometimes appears. Earth exists inside a constantly moving solar system, filled with objects travelling enormous speeds along intersecting orbital paths. The reason civilization functions normally is not because the universe stands still, it is because orbital mechanics are astonishingly reliable. The planets follow predictable paths. The moon maintains its orbit. Asteroids mostly miss. Gravity keeps everything moving with extraordinary consistency across immense spans of time. That reliability allows humans to build ordinary lives beneath extraordinary cosmic conditions. We drink coffee, we answer emails, we complain about traffic. Meanwhile, Earth hurtles through space at roughly 30 kilometers per second around the Sun, while asteroids drift nearby and stars explode across the galaxy. Reality is wonderfully strange when viewed from the correct angle, and sometime after humanity watches 2024 YR4 slip safely past the moon, attention will gradually shift toward another approaching spectacle. Not danger this time, not darkness, but a planet. Mars has always felt slightly different from the other planets. Venus is beautiful but distant somehow, wrapped in clouds so reflective and bright that ancient people often mistook it for two separate stars, one appearing at dawn and another at dusk. Jupiter inspires scale and grandeur, a giant world surrounded by storms and moons. Saturn feels elegant, almost unreal, with its rings making it resemble a carefully designed ornament placed into the solar system by an unusually artistic engineer. But Mars feels personal, partly because humans can actually imagine standing there. That matters more than people sometimes realize. Most planets remain emotionally abstract because they are clearly unlivable to ordinary imagination. Nobody casually daydreams about strolling across Neptune. The phrase itself sounds medically unwise. But Mars occupies a strange middle ground between alien world and possible future destination. It has mountains, valleys, dust storms, polar caps, sunsets, day and night cycles surprisingly close to Earth's own. Mars feels less like a distant gas giant and more like a cold neighbouring frontier waiting quietly across the cosmic street. That emotional closeness has shaped human culture for centuries. Ancient civilizations associated Mars with war largely because of its reddish appearance. The Babylonians linked it to Nergal, a god of destruction and conflict. The Romans named it after their god of war. Many cultures interpreted the red colour as blood-like or ominous in some way, which is understandable. If one wandering star glows distinctly red compared to all the others, humans will absolutely create dramatic stories about it. That is one of our most reliable species-wide behaviours. Yet despite the ancient mythology, Mars today inspires something different. Curiosity more than fear. Ambition more than superstition. Humanity increasingly treats Mars not as a symbolic object, but as a real place. A difficult place. A hostile place, but still a place. And sometime around the year 2050, Mars will stage one of its finest appearances for modern human observers. The red planet will make an unusually close approach to Earth, swelling brighter and larger in our skies than it normally appears. Not moon-sized, despite what certain misleading internet graphics periodically claim every few years. Humanity continues producing fake. Mars will look as large as the moon headlines with astonishing persistence. If Mars ever actually appeared moon-sized in the sky, civilization would likely have much larger concerns than astronomy memes. Still, during favourable close approaches, Mars becomes genuinely impressive. Bright enough to dominate sections of the night sky, distinctly red, visibly steady compared to twinkling stars, and emotionally powerful precisely because humans know it is a world. Not merely a point of light, a world. The 2050 close approach matters because planetary distances vary enormously depending on orbital positions. Earth and Mars do not circle the Sun in perfect synchronized patterns. Earth completes an orbit roughly every 365 days, while Mars takes about 687 Earth days. This means the distance between the two planets constantly changes. Sometimes they are separated by hundreds of millions of kilometers. Sometimes they swing relatively near each other during events astronomers call oppositions, when Earth passes between Mars and the Sun. Not all oppositions are equal, however. Both Earth and Mars travel along slightly elliptical orbits rather than perfect circles, so some close approaches bring the planets significantly nearer together than others. Every so often, orbital geometry aligns especially favourably, producing what astronomers call a perihelic opposition. That wonderfully complicated phrase basically means Mars and Earth are positioned unusually close together, while Mars itself sits relatively near the Sun in its own orbit. The result is spectacular. Mars brightens dramatically, its apparent size increases, telescopic details become easier to observe, and ordinary people suddenly notice the planet far more easily overhead. The close approach around 2050 is expected to be one of the best of the century. That may sound distant from our current perspective, but many people alive today could realistically witness it. A child listening tonight may stand outside as an older adult someday looking at Mars glowing brighter than they have ever seen before. That long timescale changes the emotional atmosphere again. Astronomy often stretches human imagination across decades in unusual ways. Most daily life remains very immediate, next week, next month, next year at most. Rare celestial events encourage humans to picture themselves much farther ahead. Where will I be in 2050? That question carries emotional weight. People automatically begin calculating ages, life stages, possibilities. Some listeners may imagine watching Mars with future grandchildren. Others may wonder whether humans themselves might already be walking on Mars by then. That last possibility no longer feels entirely like science fiction. And perhaps that is another reason Mars affects people differently than most planets. Humanity increasingly views it as part of our future story. No human has walked there yet. But the possibility exists visibly now. Space agencies and private companies discuss Mars missions seriously. Engineers study habitats, landing systems, radiation shielding, fuel production, and long-term survival strategies. Robots already roam its surface, sending back photographs of dusty horizons and rocky landscapes. The distance between imagination and reality has narrowed considerably, which means that when Mars brightens dramatically during close approaches, humans are no longer merely observing a distant planet. They are looking toward a place future humans may someday inhabit. That possibility changes everything emotionally. It is difficult to overstate how unusual this moment in history really is. For almost all of human existence, Mars was simply a moving red light in the sky. Ancient astronomers tracked it carefully without understanding its true nature. Early telescopic observers imagined canals and civilizations there. Science fiction transformed it repeatedly into a world of monsters, empires, deserts, and colonies. Now humanity possesses actual high-resolution images of Martian landscapes. We know what the horizon looks like there. We know what its dust sounds like against rover equipment. We know the colour of its sky during sunset. Mars stopped being mythological astonishingly recently. And still, even with all our science and robotics, the emotional impact of seeing Mars bright in the sky remains surprisingly ancient. Because brightness matters psychologically. Human beings respond emotionally to visible changes in the heavens. A brighter Mars naturally attracts attention, even from people with little interest in astronomy. During favourable oppositions, Mars becomes difficult to ignore. It glows. Not literally with its own light, of course. Mars shines by reflecting sunlight like the moon, and planets generally do. But to human perception, the reddish brightness feels vivid and alive compared to surrounding stars. Ancient observers noticed that immediately. So will future generations. And unlike many astronomical events requiring precise timing, a close Mars approach unfolds gradually over weeks and months. The planet slowly brightens night after night as Earth catches up in its orbit. Then eventually Mars reaches peak brilliance, before gradually fading again as the planets separate. There is something wonderfully patient about planetary motion. Eclipses arrive suddenly, meteor showers flash briefly. But Mars approaches like a visitor visible from increasingly farther down the road. Humans have time to anticipate it, to watch the change unfold, to compare the sky week after week. That gradual build-up creates a different emotional experience than sudden celestial events. Mars becomes a long companion in the night sky, rather than a brief interruption. And for astronomers, close approaches are invaluable scientifically too. Mars reveals more detail during favourable oppositions than at almost any other time. Even modest backyard telescopes can show polar caps, dark surface features, and dust storms under good conditions. Professional observatories gather huge amounts of data during these periods because the planet becomes easier to study. But perhaps the most interesting aspect of Mars' close approaches is not scientific at all. It is emotional projection. Humans project enormous hopes onto Mars, sometimes fears too. Mars has become a screen for imagining humanity's future in ways no other nearby planet has. Discussions about Mars quickly become discussions about survival, expansion, exploration, technology, and civilization itself. Could humans live there? Should humans live there? Would future Martian cities exist underground or beneath domes? What would children born on Mars think about Earth? Those questions sound futuristic now, yet versions of them may become increasingly practical within the lifetimes of people alive today. And all the while, Mars itself continues its ancient orbit, entirely indifferent to human speculation. That indifference feels oddly calming. The planet does not care whether humans dream about it romantically or scientifically. It simply circles the sun with reliable precision like it has for billions of years. Perhaps that reliability is partly why planetary motion feels emotionally comforting to humans. In a rapidly changing civilization, celestial cycles remain astonishingly stable. Mars approached ancient Babylon. Mars approached medieval kingdoms. Mars approached industrial cities. Mars will approach future civilizations too. The same planet, the same orbit, different humans looking upward each time, and because Mars moves visibly against the stars night after night, attentive observers experience something ancient skywatchers knew very well. Planets wander. The word planet itself comes from the Greek term for wanderer. Unlike fixed stars maintaining stable patterns, planets drift gradually through constellations over time. Ancient astronomers tracked these wanderers obsessively because their motion felt meaningful and mysterious. Mars especially attracted attention due to its retrograde motion. At certain points during close approaches, Mars appears temporarily to reverse direction against the background stars due to Earth overtaking it in orbit. Ancient civilizations found this deeply puzzling. Honestly, it is still slightly strange even once explained properly. Reality is often like that. Understanding does not necessarily eliminate weirdness. Sometimes it simply reorganizes it into equations, and sometime around 2050, countless humans may step outside to look at Mars glowing unusually large and bright overhead, while carrying all these layers of meaning simultaneously. Ancient mythology, scientific understanding, future ambition, personal memory. A bright red planet bridging past and future together in one visible point of light. Children may ask questions about astronauts. Older observers may remember previous close approaches decades earlier. Amateur astronomers will set up telescopes in parks and backyards. Some people will simply stare quietly upward, feeling the strange intimacy of seeing another world so clearly. Because that is what close Mars approaches really offer, not merely astronomy, perspective. The realization that Earth is not alone as a world orbiting the Sun, that other landscapes exist nearby, that human history unfolded beneath one small atmosphere, while neighbouring planets continued their own silent journeys alongside us. Mars reminds humanity constantly that the solar system contains destinations, not just decorations. There are objects in the solar system that feel ancient in a way planets somehow do not. Perhaps because planets appear permanent, stable, predictable. Jupiter will still be Jupiter tomorrow night. Saturn's rings will remain suspended elegantly overhead, exactly where orbital mechanics insist they should be. Comets feel different. Comets feel temporary. They arrive unexpectedly, brighten dramatically, then disappear back into darkness for years, decades, or even thousands of years at a time. Ancient people often treated them as omens precisely because they violated the normal order of the sky. Unlike stars or planets, comets wandered unpredictably from the perspective of early civilizations. A bright comet appearing overhead could feel deeply unsettling, or beautiful, or both simultaneously. And among all the comets humanity has ever observed, none carries quite the same historical weight as Halley's Comet. Because Halley's Comet does something almost no other celestial object does quite so effectively. It connects living humans directly to people from distant history. The next return of Halley's Comet is expected in 2061. That may sound far away now, but many people alive today may genuinely witness it. A child listening tonight could someday stand outside as an older adult watching one of humanity's oldest known celestial visitors blaze once again across the sky. And when that moment arrives, they will be participating in a shared human experience stretching back thousands of years. That is difficult to fully comprehend emotionally. Most astronomical objects feel detached from human timescales. Galaxies evolve too slowly. Stars live too long. Planets orbit too steadily. But Halley's Comet operates on a rhythm humans can almost emotionally grasp. Roughly every 75 to 76 years it returns, long enough that most people see it only once in a lifetime, short enough that civilizations remember it. That balance creates something unusual. Halley's Comet becomes not just an astronomical event but a generational handoff. One generation sees it, ages, tells stories about it, then eventually another generation witnesses the next return. Human history passes between appearances. The comet continues calmly regardless, and unlike many famous celestial objects, Halley's Comet has accompanied recorded human civilization for an astonishingly long time. Ancient Chinese astronomers documented likely appearances of the comet as early as 240 BCE. Babylonian records may describe it too. Medieval Europeans watched it nervously. Renaissance astronomers studied it carefully. Writers, artists, kings, sailors, scientists, and ordinary people across centuries all looked upward at the same returning object. That continuity matters emotionally. Very few things unite ancient humanity and modern humanity so directly. Imagine this for a moment. Somewhere in 1066, before the Norman conquest of England, people looked upward and saw Halley's Comet blazing in the sky. The comet became so famous during that appearance that it was later embroidered into the Bayeux Tapestry, one of history's most extraordinary surviving medieval artworks. Now imagine future humans standing beneath the 2061 return. Different languages, different technology, different civilizations entirely, same comet. The object itself will remain essentially unchanged while humanity transforms around it repeatedly. That creates a peculiar emotional sensation. Halley's Comet feels almost like a traveller moving through human history rather than through space alone, and in a sense, that is exactly what it is. The comet spends most of its time far beyond the visible planets in the cold outer reaches of the solar system. Then gravity gradually pulls it inward again toward the sun, where solar heat begins transforming it dramatically. This transformation is what makes comets so visually spectacular. A comet nucleus itself is relatively small and dark, often described as a dirty snowball, though modern astronomers sometimes prefer icy rubble pile. because it sounds slightly more dignified scientifically. These nuclei contain mixtures of ice, dust, rock, frozen gases, and ancient material left over from the solar system's formation billions of years ago. Halley's Comet is essentially carrying preserved material older than Earth's continents. That alone is extraordinary. As the comet approaches the Sun, heat vaporizes ice from the nucleus. Gas and dust stream outward into space, creating the glowing coma and long tails humans observe from Earth. Importantly, comet tails do not trail behind the comet like smoke behind a car. Solar radiation and the solar wind push the tails away from the Sun regardless of the comet's direction of travel, which means a comet moving away from the Sun can still have its tail pointing forward relative to its motion. Space continues refusing to behave intuitively whenever possible. Halley's Comet is especially famous because it becomes bright enough during favourable returns to dominate public attention worldwide. People who normally never think about astronomy suddenly step outside looking for it. And unlike brief meteors or eclipses, comets linger. They become part of the night sky for weeks or months. That lingering presence affects humans differently psychologically. A comet slowly integrates into ordinary life. People check on it nightly. Families revisit observation spots repeatedly. Newspapers publish updates. Children grow accustomed temporarily to seeing an unfamiliar glowing object overhead. Then, eventually it fades again. That fading matters emotionally. Comets are temporary visitors by nature. Humans become attached precisely because they know the experience will not last long and may never repeat within their own lifetime. The return of Halley's Comet in 1986 demonstrated this emotional complexity perfectly. Scientifically, the 1986 apparition was somewhat disappointing visually for casual observers because orbital geometry was unfavourable. The comet never became as spectacular as many hoped from Earth's perspective, yet the event still carried enormous cultural significance because it represented the return of humanity's most famous comet during the modern technological age. Spacecraft visited it, television networks covered it globally, millions of people attempted to observe it, and countless individuals quietly reflected on the realization that they would probably never see it again. That realization changes the emotional atmosphere immediately. Halley's Comet naturally encourages humans to think about mortality and time because its orbital period overlaps awkwardly with human lifespans. If you saw the comet in 1986 as an older adult, 2061 may feel impossibly distant. If you were a child then, the next return might become a major life milestone waiting somewhere ahead. Astronomy often creates these strange emotional bridges between personal time and cosmic time. Humans live short lives. Comets return patiently anyway. And yet the very fact that some people will witness multiple returns creates an unusual continuity. Imagine seeing Halley's Comet as a child in 1986 and again as an elderly person in 2061. The comet becomes a thread connecting entire decades of one human life together. Very few experiences work like that. There is also something fascinating about how comets historically changed humanity's understanding of the universe itself. For ancient civilizations, comets often represented disorder because they violated expectations about the heavens. Aristotle famously argued that comets were atmospheric phenomena occurring below the moon because the celestial realm above was believed to be perfect and unchanging. Then came Tycho Brahe in the 16th century. By carefully measuring the position of a bright comet in 1577, Tycho demonstrated that the object lay far beyond the moon. The heavens were not fixed and unchanging after all. Comets travelled through planetary space itself. That realization helped crack apart older cosmological assumptions. Again and again throughout history, astronomy keeps humbling human certainty. And Halley's Comet played a direct role in another major scientific breakthrough too. Edmund Halley, the English astronomer after whom the comet is named, studied records of bright comet appearances from 1531, 1607 and 1682. He noticed striking similarities and proposed something revolutionary at the time. These were not separate comets. They were the same comet returning repeatedly. Using Newton's newly developed gravitational theory, Halley predicted the comet would return again around 1758. He died before that return occurred. But the comet came back almost exactly as predicted. That success transformed astronomy permanently. Suddenly comets became predictable objects obeying natural laws rather than supernatural omens appearing randomly. Science replaced fear with understanding. Yet interestingly, understanding did not eliminate emotional impact. Humans still become deeply affected by bright comets even now. Perhaps because comets feel alive in a visual sense, unlike most celestial objects. Their glowing tails stretch dynamically across the sky. They change visibly, night after night. They appear to move with intention somehow despite being entirely governed by gravity and physics. The human imagination responds strongly to moving lights overhead. Always has. And Halley's comet carries additional emotional weight because of its cultural memory. It already exists inside human storytelling before it even arrives. People know its name. They know it matters historically. They know generations before them watched it too. That accumulated meaning transforms the observation experience. When future humans watch Halley's comet in 2061, they will not simply be observing ice and dust reflecting sunlight. They will be participating in a shared historical ritual stretching back across civilizations. Ancient Chinese astronomers watched it. Medieval kings watched it. Mark Twain was born shortly after its 1835 appearance and famously predicted he would die when it returned again in 1910. Remarkably, he did. Millions of future humans may someday stand outside during the 2061 return, knowing all of that history simultaneously. That layered awareness changes the sky emotionally, and perhaps the most beautiful aspect of Halley's comet is its patience. Human civilization transformed almost beyond recognition between the comet's recent appearances. In 1910, airplanes were still primitive novelties. By 1986, humanity had walked on the moon and launched probes toward the outer planets. By 2061, who knows? Human societies may look radically different again. Artificial intelligence, space exploration, climate adaptation, technologies not yet imagined. Entire political systems may shift repeatedly. Halley's comet will not care. It will continue following its orbit calmly through all of it. That indifference can feel strangely comforting. In a rapidly changing world, celestial cycles offer continuity. The comet returns because gravity says it will, not because humans deserve it or request it or remember it. Nature simply proceeds. And maybe that reliability is one reason astronomy so often feels soothing, despite dealing with enormous scales and violent phenomena. Beneath all the cosmic complexity lies remarkable order. Orbits repeat, comets return, planets rise and set. Even rare celestial events usually arrive exactly when physics predicts they should. The universe may be vast and occasionally terrifying, but it is also astonishingly consistent. One of the strangest things about astronomy is that scientists can calmly tell you what the sky will look like decades from now with extraordinary precision. Not approximately, not vaguely, precisely. Astronomers can predict eclipses centuries ahead of time. They can calculate where Mars will appear in the sky on a specific night decades from now. They can forecast asteroid flybys, planetary alignments, comet returns, and even certain stellar eruptions with remarkable confidence. Meanwhile, many of us still cannot predict where we left our keys 20 minutes ago. Humanity contains multitudes. But genuinely, if you pause long enough to think about it, celestial prediction is one of the greatest intellectual achievements our species has ever accomplished. Ancient people once feared eclipses as supernatural interruptions. Modern astronomers can calculate the exact second totality begins hundreds of years into the future. That transformation is extraordinary, and perhaps because we now live surrounded by advanced technology constantly, it becomes easy to forget how astonishing these predictions really are. Humanity has become accustomed to impossible things very quickly. Of course, scientists can tell us when Halley's Comet returns. Of course, they know exactly when Apophis will pass Earth. Of course, they can map the path of a solar eclipse decades before it happens. But none of that is obvious at all. In fact, the ability to forecast celestial events required humans to discover something profoundly important about the universe. The cosmos obeys rules, reliable rules, consistent rules, rules so stable that once understood mathematically, they allow human beings on one small planet to predict the future motion of distant objects with incredible accuracy. That realization changed civilization forever, and it began long before telescopes or computers existed. Humanity's first sky predictors were ancient observers, patiently recording patterns night after night across generations. Early civilizations noticed that celestial events repeated. The moon cycled through phases. Certain stars returned seasonally. Eclipses followed rhythms. Planets wandered in recognizable ways. At first, these patterns were practical. Farmers needed seasonal timing. Sailors needed navigation. Religious ceremonies followed celestial calendars. The sky became humanity's first clock and calendar simultaneously. Ancient Babylonian astronomers were especially remarkable in this regard. Thousands of years ago, they carefully tracked planetary motion and eclipse cycles using systematic observations. Without modern technology, they still identified repeating astronomical patterns through persistence and record-keeping alone. Imagine the patience involved, generation after generation watching the same sky carefully enough to uncover hidden cycles within it. Humans are astonishingly good pattern recognition creatures when sufficiently motivated. The Babylonians discovered eclipse cycles such as the Saros cycle, a period of roughly 18 years after which similar eclipses repeat. They did not fully understand the gravitational mechanics involved, but they recognized the rhythm. That distinction matters. Human beings often recognize patterns before understanding causes. Astronomy advanced this way repeatedly throughout history. Observers first noticed regularity. Later scientists explained why the regularity existed, and over centuries humanity gradually realized something increasingly powerful. The heavens were not random, they were measurable, predictable, mathematical. That realization accelerated dramatically during the scientific revolution. Nicholas Copernicus proposed that planets orbit the Sun rather than Earth. Johannes Kepler discovered that planetary orbits are elliptical rather than perfectly circular. Galileo used telescopes to observe celestial details directly. Then Isaac Newton unified everything through gravity. Newton's work changed astronomy completely. Suddenly the motion of planets, moons, comets, and falling apples all obeyed the same physical principles. Gravity connected Earth and sky together into one coherent system. Once that happened, prediction became vastly more powerful. If gravity governs motion, and motion follows mathematics, then future positions become calculable. The universe transformed from mysterious theatre into understandable mechanics, not less beautiful. Arguably more beautiful, because the precision involved is staggering. Take eclipses, for example. Modern astronomers can calculate the exact path of totality across Earth decades or centuries in advance, because they understand the orbital relationships between Earth, Moon, and Sun with extraordinary precision. Tiny gravitational interactions, orbital tilts, rotational speeds, and celestial distances all factor into the calculations, and the predictions work every time. The Moon arrives exactly where physics says it will. Imagine how magical that would appear to earlier civilizations. A scientist calmly announcing the precise future disappearance of the Sun years before it happens, then watching reality obey the prediction perfectly. Honestly, if someone demonstrated eclipse prediction in the distant past, they would almost certainly become either a revered scholar or an extremely concerning wizard. Perhaps both. Comets provide another fascinating example. For ancient civilizations, comets appeared chaotic and unpredictable. They emerged suddenly, lingered ominously, then vanished again. But once Newtonian gravity became understood, astronomers realized comets followed orbital paths too. Edmund Halley's prediction of the comet now bearing his name was revolutionary, precisely because it proved that even these strange wandering objects obeyed consistent laws. The comet returned exactly as expected after Halley's death. That moment mattered enormously. It demonstrated that humans could predict the future behavior of celestial objects reliably across generations. Science had learned to forecast the sky, and since then, humanity's predictive ability has become almost absurdly precise. Modern astronomers track asteroids using advanced telescopes and computational models capable of projecting orbital trajectories far into the future. Tiny gravitational effects from planets can be included. Small uncertainties can be refined continuously as new observations arrive. Thousands of near-Earth objects are monitored constantly this way. Most pose no threat whatsoever. But humanity watches carefully anyway, because prediction allows preparation. That shift from fear to foresight may be one of science's greatest emotional gifts. Ancient humans often experienced celestial events passively. Modern humans anticipate them actively. We plan trips around eclipses. We prepare telescopes for planetary oppositions. We schedule observations for meteor showers and comet returns. Astronomy became less about surprise and more about participation. Yet interestingly, prediction does not reduce emotional impact very much. People still cry during eclipses despite knowing exactly when they will happen. Halley's comet still feels emotional despite orbital calculations. Mars still inspires awe during close approaches, even though astronomers predicted the event long beforehand. Apparently the human nervous system refuses to become bored with cosmic mechanics, which is reassuring, honestly. There is another layer to celestial prediction too, one often overlooked by people outside astronomy. Scientists are not merely predicting isolated events. They are forecasting interactions within an enormously complex moving system. The solar system resembles an immense gravitational dance involving countless objects influencing one another continuously. Every planet affects every other planet slightly. Moons tug on planets. Asteroids experience subtle perturbations. Comets shift under gravitational interactions and even sunlight pressure over time. And somehow humans learn to calculate all of this well enough to forecast eclipses centuries ahead. That achievement becomes even more impressive once computers enter the story. Modern astronomical prediction relies heavily on computational modelling. Massive calculations that would once require lifetimes of human labour can now be performed rapidly using advanced software and observational data. Yet despite all the technology, the core principle remains beautifully simple. The universe is consistent. That consistency allows prediction, and perhaps consistency itself is emotionally comforting. Human civilization changes rapidly. Technologies evolve, cultures transform, political systems rise and collapse, entire generations live and disappear. Meanwhile, celestial mechanics proceed with extraordinary reliability overhead. The eclipse of 2027 is already guaranteed by orbital geometry. Halley's comet is already returning. Future planetary alignments are already unfolding invisibly right now. The universe has scheduled them long before humanity discusses them. That perspective can feel calming in a strange way. Reality continues operating according to stable principles larger than individual human uncertainty. And yet astronomy also teaches humility, because prediction has limits too. Some cosmic events remain difficult or impossible to forecast precisely. Supernovas are a good example. Astronomers understand how stars explode generally. but predicting the exact moment a specific massive star will die remains incredibly difficult. A star might explode tomorrow or thousands of years from now depending on its internal conditions. Even recurrent novas like T Coronae Borealis come with uncertainty windows rather than precise schedules. Scientists observe warning signs and estimate likely timing, but the universe occasionally keeps exact details hidden. That uncertainty preserves some mystery within astronomy. Not everything becomes fully controllable through equations, and perhaps that balance matters emotionally too. Humans seem happiest when reality remains understandable, but not entirely conquered. Too much unpredictability creates fear. Too much certainty creates boredom. Astronomy occupies a fascinating middle ground. The laws are stable. The details remain wondrous. There is also something profoundly human about our desire to predict the sky in the first place. Prediction grants psychological security. Ancient people tracked seasons because survival depended on preparation. Modern societies forecast eclipses and asteroid paths partly for science, partly for safety, and partly because humans deeply dislike uncertainty overhead. We want to know what is coming, and over thousands of years humanity gradually built systems capable of answering that desire with astonishing success. Children today grow up taking this predictive power almost entirely for granted. Astronomy apps can instantly show future planetary positions. Eclipse paths appear online years in advance. Comet visibility forecasts update automatically on phones carried casually in pockets. All of this would appear miraculous to earlier civilizations, and yet beneath the modern technology, the emotional experience remains ancient. Humans still gather beneath eclipses together, still wait for comets, still watch planets brighten, still feel awe when predictions become reality overhead exactly as expected. Perhaps because successful celestial prediction does not diminish the sky's beauty, it deepens it. Knowing that astronomers can forecast an eclipse centuries ahead makes totality feel even more extraordinary somehow. The precision itself becomes part of the wonder, everything moving perfectly together across immense distances and timescales, Earth turning, the moon orbiting, shadows racing across continents, all according to physical laws humans slowly uncovered piece by piece through curiosity and patience. Far above Earth tonight, hidden within an otherwise ordinary-looking patch of stars, there is a system astronomers watch with a mixture of excitement and nervous fascination. Not because it threatens Earth. It does not. Not because it is unusually close. It is not. But because scientists believe they may be witnessing a stellar system slowly moving toward a spectacular and extremely rare explosion. The system is called the Sagittae, and unlike many astronomical events discovered only after they happen, this one is unusual because humanity may be watching the build-up in advance. That possibility changes the emotional atmosphere entirely. Most cosmic explosions arrive without warning from a human perspective. A star brightens suddenly. A gamma ray burst flashes across space. A supernova appears where no visible star existed before. Astronomers react quickly, gather data, point telescopes, and attempt to understand what already happened. The Sagittae is different. Astronomers suspect something dramatic may happen someday in the future, perhaps around the 2080s, though the exact timing remains highly uncertain. The prediction itself attracted enormous public attention because early reports suggested the system might suddenly become one of the brightest stars visible in Earth's sky. Headlines appeared quickly. A star is going to explode. The sky may gain a new bright object. Humans could witness a rare stellar merger. Humanity reacts very enthusiastically whenever scientists casually mention future explosions. And to be fair, the underlying science genuinely is fascinating. The Sagittae is not a single star but a binary system, meaning two stars orbit each other closely while locked in a gravitational relationship that has become increasingly unstable over time. Astronomy is full of systems like this. Stars rarely exist entirely alone. Many belong to binary or multiple star systems where gravity ties them together across immense spans of time. Sometimes these relationships remain stable and peaceful, sometimes they become catastrophic. V Sagittae appears to belong firmly in the second category. The system consists of two stars orbiting so closely that material transfers continuously between them. One star is compact and extremely hot. The other loses material steadily to its companion through gravitational interaction. That transfer process matters enormously because it alters the entire future of the system. Imagine two figure skaters spinning while one continuously throws mass toward the other. Their motion changes, energy redistributes, stability becomes increasingly difficult. Now replace the skaters with stars containing enormous amounts of matter and radiation. Space becomes dramatically more interesting very quickly. Astronomers became especially intrigued by V Sagittae because the orbital period of the stars appeared to be shrinking unusually rapidly. The two stars were spiraling closer together faster than expected. That observation suggested something important. The system may eventually merge, and stellar mergers are extraordinary events. When stars merge, enormous amounts of energy can be released. Brightness can increase dramatically. The surrounding system can transform completely. Depending on the stars involved, the result may resemble a nova or even produce an entirely new type of stellar object afterward. In the case of V Sagittae, astronomers proposed that the system could someday erupt in a luminous red nova, an explosion bright enough to become visible to ordinary human observers from Earth, a new star potentially appearing in the sky again. Humanity remains deeply emotional about those. What makes this story especially fascinating is not merely the possible explosion itself, but the idea that scientists might predict such a thing ahead of time. That possibility feels almost unsettlingly modern. Ancient humans experience celestial surprises unexpectedly. Modern humans increasingly receive previews. Imagine explaining this situation to someone from centuries ago. Yes, astronomers believe two stars are gradually spiraling together and may explode visibly sometime around the late 21st century. That sentence contains several concepts that would sound entirely magical historically. Yet modern astrophysics allows scientists to investigate stellar systems in astonishing detail. Astronomers can measure orbital periods, analyze light spectra, estimate masses, calculate temperatures, track brightness variations, and model how stars evolve over time. Humanity has learned to diagnose distant stars. That remains one of civilization's most absurd achievements when viewed from the correct angle. These objects are incomprehensibly far away. And yet humans sitting on one small planet can infer what they are doing through careful observation and mathematics. Still, V Sagittae also demonstrates something important about science. Predictions evolve. Later studies suggested the original merger timeline may have been too aggressive. Additional observations indicated the system's behavior was more complicated than initially believed. The dramatic 2083 prediction became less certain, and that uncertainty matters because it reveals how science actually works. Astronomy is not prophecy. Scientists do not gaze mysteriously into telescopes and announce cosmic destinies with absolute certainty. They gather evidence, build models, revise conclusions, and improve understanding continuously as new information appears. Sometimes the universe behaves differently than expected. That is not scientific failure. That is science functioning correctly. Human beings often misunderstand this process emotionally because we crave certainty. We prefer simple declarations. Will the star explode or not? Reality rarely cooperates so neatly. V Sagittae remains genuinely strange and genuinely important scientifically, even if the exact timeline proves uncertain. The system still appears unstable. The stars still interact violently. The future still likely involves dramatic transformation eventually. The universe simply refuses to provide humans with a perfectly convenient countdown timer. which honestly feels very on brand for astronomy. Yet even uncertainty does not diminish the emotional power of the idea itself. Somewhere out there, two stars may currently be spiraling toward eventual merger, while humanity quietly watches from afar. That thought creates a fascinating emotional contrast. Human life feels fast from inside it. Years pass quickly. Civilizations transform rapidly. Technology evolves almost chaotically. Stars normally feel slow, impossibly slow. But systems like V Sagittae temporarily compress stellar evolution into something humans can emotionally engage with on more familiar timescales. Suddenly, a star system possesses a future event, potentially reachable within living memory. That changes how people relate to it psychologically, and perhaps more than any other science, astronomy repeatedly shifts human perspective on time itself. A human lifespan is short compared to stellar evolution. A civilization is brief compared to galactic motion, yet occasionally, cosmic processes align closely enough with human timescales that we become direct witnesses to change. A nova brightens within days, a comet returns within decades, a stellar merger may unfold within generations. These moments feel emotionally special precisely because they narrow the immense gap between human time and cosmic time. For a little while, the universe appears active on scales we can personally grasp. There is another reason V Sagittae fascinates people too. Humans are naturally drawn towards stories involving build-up. We like tension, anticipation, future possibility. That instinct appears everywhere in human storytelling. Movies, novels, myths, history. The knowledge that something significant may happen creates emotional investment long before the event itself arrives. V Sagittae functions almost like a cosmic suspense story, unfolding across decades. Astronomers continue observing. The stars continue orbiting. The future remains uncertain but intriguing. And somewhere ahead, perhaps long after many of us are gone, the system may dramatically brighten in Earth's sky. That possibility alone becomes part of human imagination. Future generations may grow up already aware of the system's unusual behaviour. Children not yet born may someday hear adults discussing V Sagittae the way people today discuss future eclipses or comet returns. Maybe this is the decade it happens. That ongoing anticipation becomes culturally interesting, and if the eruption eventually does occur visibly from Earth, the emotional impact could be extraordinary. Imagine humanity collectively watching news spread that a star has suddenly become dramatically brighter in the sky. Not a satellite launch, not an artificial object, a real stellar event unfolding across space. Even knowing the physics behind it would not reduce the emotional power very much. Humans remain deeply responsive to visible sky changes because our species evolved beneath stable heavens. The stars normally appear fixed and eternal. When one visibly transforms, ancient instincts still activate somewhere deep in the brain. Astronomy repeatedly reveals that knowledge and wonder coexist beautifully. Understanding the mechanisms behind eclipses does not ruin totality. Knowing how comets work does not diminish their beauty. Learning stellar physics does not make exploding stars emotionally ordinary. If anything, the science intensifies the experience because humans understand what they are truly witnessing: a stellar merger, energy on unimaginable scales, matter rearranging itself through gravity and thermonuclear processes, two stars ending one stage of existence and beginning another. And somewhere below that event, on one tiny planet orbiting an ordinary star, billions of humans continuing their daily routines while occasionally glancing upward in amazement. There is something comforting about that perspective too. Human life often feels overwhelmingly immediate. Bills, deadlines, politics, responsibilities, anxieties. Astronomy gently stretches awareness outward again. It reminds us reality contains events operating on scales far beyond ordinary concerns. Not in a dismissive way. Your life still matters enormously within your own world, but cosmic perspective can soften certain kinds of stress. The stars continue regardless. The universe remains vast and dynamic and astonishing whether humans worry productively or not. And perhaps that is one reason people find astronomy soothing at night specifically. The sky feels larger than personal tension. V Sagittae embodies that feeling beautifully because it combines uncertainty, scale, science, and anticipation together into one story. The system reminds humanity simultaneously how much we understand and how much still remains uncertain. We can detect stellar instability from incredible distances, yet exact outcomes still evade us. The universe remains partially mysterious. That balance may be ideal, honestly. A fully understood cosmos might feel emotionally smaller somehow. Mystery preserves curiosity. Curiosity preserves wonder. And while astronomers continue watching for Sagittae carefully across coming decades, another future spectacle waits even farther ahead near the close of the century. There are some sights in astronomy that feel dramatic immediately. Anasius eclipse swallowing the sun, a comet stretching across the sky, a meteor blazing overhead. You see them once and instantly understand why humans remember them for generations. Then there are other celestial events that are quieter, more delicate, events that reveal beauty not through violence or spectacle, but through precision. The future alignment of Jupiter's great moons belongs very much to that second category. Sometime around the year 2092, astronomers expect one of the rarest and most elegant orbital arrangements in the solar system to unfold. Jupiter's 4 largest moons, Io, Europa, Ganymede, and Callisto, may appear aligned in an unusually precise configuration visible from Earth. Not simply roughly lined up, the way headlines sometimes describe ordinary planetary events with suspicious enthusiasm. Humans have a habit of calling almost anything in the sky a rare alignment, if enough planets vaguely occupy the same general direction. No, this event is genuinely special, because Jupiter's moons do not merely orbit randomly around the giant planet. They move according to an intricate gravitational rhythm so stable and mathematical that astronomers often describe the system as a celestial clock, and perhaps nowhere in the solar system is orbital harmony more beautiful than around Jupiter. Now, when most people think about Jupiter, they think about size first. That makes sense. Jupiter is enormous, truly enormous. If Earth were the size of a grape, Jupiter would be roughly the size of a basketball. More than 1,300 Earths could fit inside Jupiter by volume. The planet dominates the solar system so thoroughly that it contains more mass than all the other planets combined. It is less a planet and more a small failed star that narrowly missed becoming something even stranger. And surrounding this giant world is an entire miniature solar system of moons. Scientists currently know of more than 90 moons orbiting Jupiter, though new tiny irregular moons continue turning up occasionally because Jupiter apparently collects satellites the way some people collect unread books. But among all those moons, 4 stand apart: Io, Europa, Ganymede, Callisto, the Galilean moons, named after Galileo Galilei, who discovered them in 1610 using one of the earliest telescopes ever pointed seriously toward the heavens. That discovery changed humanity's understanding of the universe forever, because before Galileo observed Jupiter's moons, many people still believed everything in the cosmos revolved around Earth. But here, clearly visible through a telescope, were 4 objects orbiting something else, not Earth, Jupiter. It was a deeply unsettling observation for older models of the cosmos. Reality had begun refusing to cooperate with human assumptions again, and ever since then, the Galilean moons have fascinated astronomers continuously because each one is extraordinary in its own way. Io is the most volcanically active world in the solar system. covered in erupting sulfur volcanoes driven by immense gravitational stresses. Europa hides a vast subsurface ocean beneath its icy crust, making it one of the most promising places to search for extraterrestrial life nearby. Ganymede is the largest moon in the solar system, larger even than the planet Mercury. Callisto remains ancient and heavily cratered, preserving billions of years of impact history across its battered surface. 4 worlds, 4 entirely different stories, all orbiting Jupiter in a complex gravitational dance. And it is that dance that makes the alignment of 2092 so fascinating. Because the inner 3 moons, Io, Europa and Ganymede, are locked together in what astronomers call orbital resonance. This is one of the most elegant concepts in celestial mechanics. Their orbits synchronize mathematically. For every orbit Ganymede completes, Europa completes exactly 2, and Io completes exactly 4. The moons repeatedly tug gravitationally on one another with rhythmic precision, maintaining this resonance across immense spans of time. Imagine 3 dancers moving around a stage while always returning to particular positions relative to one another, at perfectly timed intervals. Now imagine those dancers are worlds. That is orbital resonance. And resonance matters enormously because it shapes the moons, physically too. Europa's hidden ocean and Io's volcanic fury both result partly from gravitational interactions within this resonance system. The moons continuously flex slightly under tidal forces, generating internal heat. Gravity literally kneads these worlds like cosmic dough. The universe occasionally sounds ridiculous when explained honestly, yet the mathematics involved are breathtakingly precise. Astronomers can calculate the positions of Jupiter's moons centuries into the future because the laws governing their motion remain so stable. Just as eclipses can be predicted long before they occur, orbital alignments unfold according to gravitational choreography already written into the future of the solar system. That idea remains astonishing. Right now, while humanity sleeps and argues and builds cities and forgets passwords, Jupiter's moons continue their dance exactly as physics demands. The alignment of 2092 is already happening, slowly, inevitably. And somewhere far ahead, future humans may look through telescopes and witness an arrangement so geometrically elegant that it feels almost designed. Humans are extremely sensitive to symmetry and alignment psychologically. We respond emotionally to patterns, musical harmony, architectural balance, repeated rhythms, synchronized movement. The brain finds order satisfying. Astronomy provides that satisfaction constantly for people patient enough to notice. Jupiter's moons are especially beautiful because their motion is visible on human timescales. Unlike many astronomical processes unfolding too slowly to observe directly, the Galilean moons visibly shift positions night after night. Even small telescopes reveal this. A person with modest equipment can watch the moons move around Jupiter over just a few hours. Tiny points of light changing position in real time, shadows crossing Jupiter's cloud tops, moons disappearing behind the planet and re-emerging later. It feels alive, dynamic, like observing a tiny mechanical model of the solar system operating overhead. Galileo himself reportedly became deeply emotional observing these motions because they proved the heavens were not fixed and unchanging. Things moved. Worlds orbited other worlds. The cosmos possessed structure and motion far more complicated than earlier generations imagined. That realization still feels powerful today. And sometime around 2092, future observers may witness one of the finest demonstrations of that celestial structure imaginable. Not through explosions or darkness or danger, through alignment, pure orbital precision. There is something wonderfully calm about that. Many cosmic events discussed in this journey involve violence or instability, exploding stars, passing asteroids, potential impacts, stellar mergers. But Jupiter's moons remind us that the universe also produces extraordinary beauty through stability. Gravity creates chaos sometimes, it also creates harmony. The solar system itself exists because gravity organized matter into long-term patterns billions of years ago. Planets orbit. Moons circle planets. Resonances emerge. Stability develops. And occasionally those stable systems produce moments of startling visual elegance. Future astronomers will almost certainly prepare extensively for the 2092 alignment. Observatories will track the event carefully. Amateur astronomers will set up telescopes worldwide. Space agencies may even have robotic missions already operating near Jupiter by then, sending close-range images back to Earth. Think about that possibility for a moment. Humans alive today may not live to see the alignment itself, but future generations could witness it using technologies not yet invented, while perhaps already maintaining scientific outposts throughout the solar system. And still, the emotional core of the experience will remain ancient. People looking upward at moving lights in the sky. That continuity matters. Technology changes rapidly. Human curiosity does not. The same instinct that drove ancient skywatchers to map wandering stars now drives modern astronomers to study orbital resonances around giant planets. Humanity remains fundamentally fascinated by patterns overhead. Perhaps because celestial order feels reassuring. The universe often appears chaotic from Earth's perspective. Weather shifts unpredictably. Human. Societies change rapidly. History twists in unexpected directions. Then you look at Jupiter's moons. Orbit after orbit after orbit. Reliable, precise, steady. A gravitational rhythm continuing for billions of years. That reliability can feel almost comforting emotionally. Especially at night, astronomy often functions less like information and more like perspective. The sky reminds humans that larger systems continue operating calmly beyond ordinary daily anxiety. And Jupiter itself contributes enormously to that feeling because it dominates the night sky so confidently when visible. Bright, steady, unmistakable. Ancient cultures often associated Jupiter with kingship or divine authority, partly because it moves through the heavens with such obvious importance. Even now, anyone casually glancing upward can usually identify Jupiter immediately once they know where to look. It does not twinkle like stars. It shines steadily, calmly. A giant world reflecting sunlight across hundreds of millions of kilometers. And beside it, invisible to naked eyes but waiting patiently for telescopes, its moons continue tracing mathematical paths with astonishing fidelity. There is another fascinating aspect to orbital alignments too. They reveal time physically. Human beings usually experience time internally through aging, memory, and routine. Astronomy externalizes time. Orbital motion becomes visible evidence that time is passing. The moon changes phase, planets shift position, comets return, Jupiter's moons circle endlessly. The cosmos keeps time openly. And perhaps that is why astronomy feels especially powerful late at night. Darkness removes many ordinary distractions, allowing humans to notice these larger rhythms again. A person standing quietly beneath the stars experiences time differently than someone staring at clocks indoors. The universe slows the mind slightly, or maybe it simply reminds us that not everything needs to move at human speed. By 2092, humanity itself may look radically different. Cities may transform. Technologies may evolve beyond recognition. Human beings may travel regularly through space. Artificial intelligence may reshape civilization in ways difficult to imagine fully now. Jupiter's moons will continue orbiting exactly as before. That continuity across generations is deeply beautiful somehow. And after future observers witness one of the rarest alignments in the Jovian system, humanity will still continue looking upward, searching for the next unusual thing the cosmos chooses to reveal. Long before telescopes, satellites, observatories, or astronomy apps glowing softly on bedside tables, human beings already watch the sky with extraordinary attention. In some ways, ancient people may have noticed the heavens more carefully than most modern humans do. That is not because they were more intelligent or more spiritual, or magically connected to nature in some mysterious forgotten way. Ancient people were simply immersed in the sky constantly. Without electric lighting, the night above them was darker, clearer, and impossible to ignore. The stars were not hidden behind urban brightness or apartment ceilings. They were part of ordinary life every single evening. And when something unusual happened overhead, people noticed immediately. A comet appearing suddenly, a new star where none existed before, the sun darkening unexpectedly, the moon turning red. These events felt enormous because the sky itself felt permanent. Imagine living in a world where celestial stability is one of the few reliable constants in life. Seasons change, kingdoms rise and fall, crops fail, wars begin, but the stars remain where they belong. Then one night the heavens change. It is difficult to overstate how emotionally powerful that would feel. Modern humans often encounter rare astronomical events already prepared psychologically. We know eclipses are coming years ahead of time. We understand comets scientifically. We expect meteor showers seasonally. Ancient sky watchers usually did not possess that certainty. The sky could surprise them, and those surprises shaped history repeatedly. One of the most famous examples occurred in the year 1054, with the appearance of the supernova now associated with the Crab Nebula, catalogued today as Messier 1, or M1. At the time, however, nobody called it that. To people living across parts of Asia and the Middle East, it was simply a shocking new light in the heavens. Chinese astronomers documented the event carefully, describing a guest star visible even during daylight for weeks. Japanese records likely reference it too. The object remained visible in the night sky for nearly 2 years before gradually fading away. Think about how astonishing that must have been. A star suddenly appearing bright enough to shine in daytime. For ancient observers, this directly challenged the idea that the heavens were fixed and eternal. The sky itself seemed alive and unstable. Today we know the event was a supernova explosion roughly 6,500 light-years away. A massive star ended its life catastrophically, ejecting material outward into space while leaving behind a neutron star spinning rapidly at the center of the expanding nebula. The Crab Nebula still exists today. Modern telescopes reveal glowing filaments expanding outward from the ancient explosion. Humanity can literally observe the aftermath of the same event ancient skywatchers witnessed nearly 1,000 years ago. That continuity is extraordinary. And it was not the only time celestial events altered human perception dramatically. In 1572, another famous supernova appeared in the constellation Cassiopeia. Today, astronomers call it SN 1572, or Tycho's supernova, because the Danish astronomer Tycho Brahe studied it intensely. At first glance, the event may sound similar to the Crab supernova centuries earlier, a bright new star appearing unexpectedly. But historically, the impact was enormous. Tycho carefully measured the object's position and discovered something revolutionary. The supernova showed no detectable parallax relative to distant stars, meaning it lay far beyond the moon. This mattered because prevailing European cosmology at the time still followed Aristotelian ideas claiming the heavens were perfect and unchanging. Celestial perfection formed part of the philosophical structure of the universe itself. Then the universe interrupted politely but firmly with an exploding star. Tycho's observations helped dismantle older cosmological assumptions permanently. The heavens could change after all. Astronomy repeatedly humbles certainty that way. And only a few decades later, another celestial visitor transformed human understanding again, Halley's Comet. Specifically its appearance in 1682, carefully studied by Edmund Halley himself. Halley realized this comet resembled earlier comets recorded in 1531 and 1607. Using Newton's laws of gravity, he proposed something astonishing for the time. These were not separate comets at all, but the same object returning periodically. He predicted it would come back again in 1758, and it did. That successful prediction changed science profoundly because it demonstrated that even seemingly chaotic comets obeyed mathematical laws. The sky was not random theatre directed by supernatural forces. Celestial motion followed predictable rules. The heavens became understandable, not fully conquered certainly, but understandable. There is another famous comet that affected human history emotionally, long before Halley's prediction too. The Great Comet of 1066, now identified as an appearance of Halley's comet itself, became deeply intertwined with one of the most important political events in medieval Europe, the Norman conquest of England. The comet appeared shortly before the Battle of Hastings and was interpreted widely as an omen. The famous Bayeux tapestry even depicts people pointing fearfully toward the object overhead. One little glowing visitor crossing the sky while kingdoms change below. Astronomy and human history intertwine constantly like that, and sometimes celestial events shape not only politics or philosophy, but survival itself. Take the Carrington event of 1859. Unlike comets or supernovas, this was a massive solar storm, the largest geomagnetic event ever reliably recorded in modern history. The event followed an enormous solar flare observed independently by astronomers Richard Carrington and Richard Hodgson. The resulting coronal mass ejection slammed into Earth's magnetic field with astonishing intensity. Auroras appeared near the equator. Telegraph systems failed across continents. Operators received electric shocks. Some telegraph lines reportedly continued functioning briefly even after power supplies disconnected because the atmosphere itself had become electrically charged enough to induce current. Imagine living through that. The sky glowing red worldwide while human technology malfunctioned unpredictably beneath it. At the time, industrial civilization remained relatively young. Today, a Carrington-level event would threaten satellites, communication systems, electrical grids, navigation networks, and enormous portions of modern infrastructure. The sun itself suddenly becomes emotionally different once you realize it can occasionally throw space weather tantrums powerful enough to disrupt civilization. Reality remains exciting. Then there are eclipses. Throughout history, eclipses repeatedly influence battles, diplomacy, and religious interpretation, because few celestial events feel more immediate emotionally than daytime darkness. One famous example occurred in 585 BCE during a battle between the Medes and the Lydians. According to historical accounts, a solar eclipse interrupted the conflict so dramatically that both sides interpreted the darkness as a sign to stop fighting and negotiate peace. Imagine an entire battle ending because the sun vanished overhead. Modern humans know eclipses are orbital mechanics. Ancient armies saw divine intervention. Same event, completely different psychological framework. And eclipses continued affecting history even after scientific understanding improved. Christopher Columbus famously used knowledge of a predicted lunar eclipse in 1504 to intimidate indigenous communities in Jamaica after his crews became stranded and desperate for supplies. He warned local inhabitants that his god would darken the moon in anger if assistance was refused. Then the eclipse occurred exactly as predicted. Astronomy can become deeply persuasive under the correct circumstances, though admittedly using orbital mechanics to frighten people into cooperation is not the most wholesome chapter in scientific history. Still, the event demonstrates how celestial prediction shifted power dramatically once humans learned to forecast the sky accurately. And perhaps no astronomical object influenced civilization more consistently than Venus. Not through rare explosions or catastrophic events, but through predictable appearances carefully tracked across cultures worldwide. Venus appears alternately as the morning star and evening star depending on orbital position, and many ancient civilizations built calendars and rituals around these cycles. The Maya in particular studied Venus with astonishing precision. The Dresden Codex contains detailed Venus tables tracking its appearances and disappearances with remarkable accuracy. Again, this happened long before modern telescopes existed. Human beings have always been astonishingly persistent skywatchers. Then there are meteor storms. In 1833, the Leonid meteor storm produced one of the most intense meteor displays in recorded history. Thousands upon thousands of meteors streaked overhead every hour across North America. Observers described the sky as raining fire. People woke terrified. Some believed Judgment Day had arrived. Others simply stood outside speechless, watching the heavens erupt with motion. The event deeply influenced public awareness of meteor astronomy and inspired scientific investigation into the connection between meteors and comet debris. Once more, rare celestial spectacle pushed human understanding forward. Astronomy advances partly through surprise, and surprise continues even now. Consider Comet Shoemaker-Levy 9 in 1994. Humanity watched fragments of a comet collide directly with Jupiter. For the first time in history, modern civilization witnessed major impacts happening visibly elsewhere in the solar system. Dark scars larger than Earth appeared temporarily across Jupiter's atmosphere after the collisions. The emotional effect was profound. Suddenly, asteroid impacts no longer belonged solely to distant geological history. Humans watched planetary collisions occur in real time. The solar system felt more active afterward, more alive, perhaps slightly more dangerous too. And then there was SN 1987A, the famous supernova in the Large Magellanic Cloud. It became the closest observed supernova since Kepler's supernova in the 1604 and allowed modern astronomers to study stellar death in unprecedented detail using contemporary instruments. Neutrino detectors even captured particles from the explosion before visible light fully arrived. Humanity literally sensed a dying star before seeing it. That sentence alone sounds almost mythological, yet it happened. And through all these events, one pattern repeats continuously. Rare celestial phenomena change how humans see themselves, not only scientifically, emotionally. A supernova challenges assumptions about permanence. A comet connects generations across centuries. An eclipse interrupts ordinary daylight with cosmic precision. A meteor storm reveals the atmosphere immersed within larger celestial systems. A solar storm reminds civilization that even the sun can become disruptive. Again and again, astronomy stretches human awareness beyond ordinary daily life. And perhaps that is why these events remain memorable long after scientific explanations arrive. Humans do not merely learn facts during rare cosmic spectacles. We experience perspective shifts. The universe briefly feels larger, stranger, and more active than usual. Ancient humans felt this intensely because the sky governed survival and meaning directly. Modern humans still feel it despite technology, because the emotional architecture underneath remains ancient. We are still creatures evolved beneath changing skies, still animals that look upward when something unusual happens overhead, still deeply affected by rare lights in darkness, and as future generations witness novas, eclipses, comets, asteroid flybys, planetary alignments, and perhaps even stellar mergers in centuries ahead, they will continue participating in the same ancient tradition. Humans watching the heavens carefully, trying to understand what they mean, trying to understand what they mean for us. There is something unusual that happens to human beings during rare celestial events. Something social, something emotional, something ancient. People gather, not always intentionally at first. Sometimes it begins casually. A few neighbours standing outside during an eclipse, families bringing lawn chairs into open fields for meteor showers, strangers clustering around telescopes in parks while someone points upward saying, "There it is." Then suddenly hundreds or thousands or even millions of people are all looking at the same thing together. Modern life does not create many moments like that anymore. Most human attention is fragmented constantly. Different schedules, different devices, different algorithms feeding different realities into different screens. Entire societies often feel psychologically scattered across countless separate worlds. But rare cosmic events interrupt that fragmentation briefly. The sky becomes shared again. And perhaps that is why humans respond so strongly to these events emotionally. Not merely because the cosmos itself is impressive, but because astronomical spectacles temporarily reconnect people to collective experience in ways modern civilization rarely does. Think about what happens during a total solar eclipse. Cities prepare months or years ahead. Schools distribute eclipse glasses. Highways fill with travelers moving toward the path of totality. Hotels sell out. Weather forecasts suddenly become emotionally important to people who normally ignore meteorology entirely. Then, on the day itself, strangers gather outdoors together, not inside stadiums, not in shopping centres, outside, beneath the sky. And once totality arrives, something fascinating happens to the crowd. People become quiet. Even enthusiastic, noisy groups often fall silent for a moment when the sun disappears completely. There are usually gasps first, certainly, sometimes applause afterward. But during the deepest moments of totality, many crowds enter a kind of collective stillness, humans instinctively recognizing something larger than themselves together. That experience is psychologically powerful. Scientists studying awe have found that experiences involving vastness, beauty, and perceptual surprise can temporarily alter human thinking and emotional behavior. People often become more cooperative, less self-focused, and more emotionally connected after awe-inducing experiences. Rare cosmic events produce exactly those conditions. The scale feels enormous, the event feels beyond human control, the environment changes dramatically, and everyone present experiences it simultaneously. That combination is rare, very rare. Perhaps that is why people travel extraordinary distances for celestial events despite the inconvenience involved. Rationally speaking, many astronomical spectacles are brief. A total eclipse may last only minutes. Meteor showers peak overnight. Comets eventually fade. Yet humans willingly cross continents to witness them. Not because the events are practical, because they feel meaningful. And meaning matters profoundly to social creatures like us. There is an interesting contradiction here too. Astronomy often emphasizes human smallness. The universe is vast beyond ordinary comprehension. Earth is tiny. Human civilization occupies only a thin layer of time across cosmic history. Yet instead of making people feel hopeless, rare celestial events frequently produce the opposite effect. Connection, humility certainly, but also connection. Perhaps because shared awe reduces isolation. A person standing alone beneath an eclipse feels astonished. A crowd standing together beneath an eclipse feels united. That difference matters emotionally. Humans evolved in groups. Our nervous systems remain deeply social even when modern life encourages individual isolation. Shared experiences affect us strongly because collective attention historically meant survival. If everyone suddenly stared upward at something unusual, it probably mattered. Rare sky events activate that ancient instinct beautifully. Even today, if a bright meteor streaks overhead during a gathering, conversations stop instantly. Every head turns upward together automatically. No training required. Human attention synchronizes almost immediately. And synchronization itself changes emotional experience. Crowds observing celestial events often describe feeling unusually connected to strangers around them. People share binoculars, help others identify planets, explain constellations to children they have never met before. Astronomy temporarily softens social boundaries, perhaps because the sky belongs equally to everyone. That equality is surprisingly important psychologically. Many modern experiences are filtered through status, wealth, geography, or access. But eclipses cross borders. Comets appear above rich and poor alike. Meteor showers ignore politics completely. The universe remains wonderfully uninterested in human hierarchy. And maybe humans find that refreshing. There is also something deeply ancient about gathering outdoors collectively at night. Before electric lighting transformed civilization, humans spent far more time beneath visible stars. Night skies once shaped ordinary social life directly. Families, travellers, farmers, sailors, entire communities lived with constant awareness of celestial cycles. Modern urban life dimmed much of that connection. Many people now rarely see truly dark skies at all. Yet during major cosmic events, humans instinctively return outdoors together anyway, almost as though some older cultural memory briefly reactivates. Meteor showers are especially good at producing this feeling. Unlike eclipses, meteor showers often unfold slowly across entire evenings. People lie on blankets, conversations drift quietly. Telescopes become less important because the experience works best with naked eyes and patience. Meteor watching encourages stillness, and stillness is increasingly rare. Perhaps that alone explains part of astronomy's emotional appeal. Rare sky events give humans permission to pause collectively for a while, to stop multitasking, to look upward without productivity attached. No one watches an eclipse efficiently. No one optimizes a comet emotionally. The experiences resist modern urgency, and because celestial events often arrive infrequently, they naturally create anticipation too. Anticipation strengthens emotional memory enormously. Humans begin imagining future cosmic events long before they occur. Families plan eclipse trips years ahead. Amateur astronomers wait decades for comet returns. Children hear about future alignments they may someday witness as adults. The future becomes emotionally tangible through astronomy. That may be one reason people grow so attached to scheduled celestial events. They become landmarks waiting ahead in time. Someday we'll see Halley's Comet. That eclipse happens when you'll be older. Maybe we'll watch Mars together then. Those conversations matter because they connect people across generations. Astronomy repeatedly creates intergenerational experiences in ways few modern activities do. Grandparents explain constellations to children. Parents share stories about previous eclipses. Families remember where they watched famous celestial events together decades earlier. The sky becomes family history. And perhaps because celestial events transcend ordinary politics and culture, they also create unusual moments of global simultaneity. When major eclipses occur, millions of people across multiple countries often experience the same emotional event within minutes of one another. News coverage spreads instantly. Social media fills with shared images and reactions. Different languages describe the same sky. For a brief moment, humanity becomes synchronized around something larger than itself. That synchronization feels rare enough now to become emotionally powerful, almost automatically. There is another layer here too, fear. Not panic exactly, at least not usually in modern times, but fear remains historically intertwined with celestial events because the sky once represented uncertainty and vulnerability directly. Ancient humans feared eclipses partly because the sun's disappearance threatened the stability of reality itself. Comets frightened societies because they seemed unpredictable and disruptive. Meteors and novas violated expectations about how the heavens were supposed to behave. Even modern humans retain faint traces of these instincts. Why do asteroid headlines spread so quickly? Why do blood-red lunar eclipses still feel slightly eerie despite complete scientific understanding? Why do people instinctively gasp during totality even when fully prepared? Because the emotional brain reacts first. Rare cosmic events temporarily remind humans that the universe is dynamic rather than static. Things move, objects pass nearby, stars explode, shadows race across Earth, the sky is active, and activity overhead naturally commands attention from creatures evolved beneath open skies. But importantly, modern astronomy transformed fear into fascination more often than not. Humans no longer gather beneath eclipses to beg the sun to return. We gather to witness beauty. That transformation represents one of science's greatest cultural achievements. Understanding reduced terror without reducing wonder, maybe even enhanced wonder. Knowing why eclipses happen makes them more extraordinary in some ways, because the precision involved becomes visible. Knowing comet orbits does not ruin their beauty. Knowing stars explode through nuclear physics does not make novas emotionally ordinary. Science and awe coexist comfortably. And when humans gather together beneath rare skies now, the atmosphere usually contains curiosity more than fear. Children ask questions, strangers compare observations, crowds cheer when totality arrives. That emotional shift from dread towards shared curiosity may say something hopeful about civilization itself. Humanity learned to transform celestial fear into collective exploration. Of course, not every cosmic event becomes joyful immediately. Asteroid flybys still provoke anxiety sometimes. Potential impacts understandably attract public attention. But even then, modern astronomy introduces something ancient societies lacked: preparation, prediction, understanding. Humans no longer face the sky helplessly. We calculate, monitor, forecast. And because we understand the mechanics involved, rare cosmic events increasingly become opportunities for connection rather than panic. There is also something emotionally comforting about how temporary these events are. The eclipse ends, the comet fades, the meteor shower quiets, ordinary life resumes. Temporary experiences often affect humans more strongly, precisely because they do not last. Psychologists sometimes call this scarcity value. Humans emotionally intensify experiences perceived as rare or fleeting. Astronomy is filled with fleeting things. That is why people travel enormous distances for mere minutes of totality. The rarity itself creates meaning, and unlike manufactured entertainment, celestial events feel authentic in a very deep sense. No corporation designed an eclipse, no algorithm optimized Halley's Comet for engagement metrics. The universe simply produces these spectacles naturally through gravity, motion, and physics. Humans respond strongly to that authenticity. Perhaps because modern life contains so many artificial systems competing for attention constantly. Rare sky events cut through all of it immediately. The cosmos does not ask permission to become beautiful overhead. It simply happens, and when it does, humans gather almost automatically, not because we are told to, because something inside us still recognizes the importance of looking upward together. That instinct may never disappear completely. Even future humans living in advanced technological civilizations may still gather outdoors for eclipses and comets and planetary alignments because the emotional experience reaches deeper than culture or technology alone. Awe is ancient. So is curiosity. So is the need to share extraordinary moments with others. And perhaps that is ultimately why rare cosmic events matter so much to people. Not because the universe changes. The universe is always changing. These moments matter because they briefly change us. They interrupt routine, stretch perspective, create memory, reconnect strangers, remind humans that beneath all our divisions and distractions, we still occupy one small moving world together under one evolving sky. And somewhere above us tonight, even now, the next rare celestial event is already quietly approaching. For most of human life, the universe feels quiet. Not silent exactly, but steady. The stars rise where we expect them to rise. The moon keeps its familiar rhythm. Seasons return. Constellations drift slowly across the year with such reliability that entire civilizations once built calendars and myths around them. And because this stability surrounds us constantly, it becomes easy to forget something important. The sky is not still. It only appears still because human lives are short. Above us tonight, stars are moving. Galaxies are rotating, asteroids are drifting silently through darkness. Distant worlds continue circling their suns. Gravity keeps shaping everything patiently, whether anyone notices or not. The universe is always doing something. Most of the time, we simply do not live long enough to see the changes directly. But every now and then, cosmic time and human time overlap just enough for us to witness something rare. A star suddenly brightens. An eclipse darkens noon. A comet returns after generations. A planet grows unusually large in the sky. An asteroid glides close enough for ordinary people to step outside and watch it moving overhead. And for a little while, humanity remembers where it actually lives. Not inside buildings, not inside schedules, not inside screens. On a planet. A small planet moving through space beneath an active universe. Perhaps that is why rare cosmic events feel so emotional to people. They interrupt the illusion that daily life is the entire story. For a brief moment, ordinary concerns loosen slightly and something much larger enters awareness again. Bills still exist afterward, unfortunately. Laundry remains undefeated. Emails continue arriving with astonishing confidence. Yet for a little while, the cosmos becomes impossible to ignore. And maybe humans need that sometimes. Not because the universe exists to comfort us specifically. It does not. Stars are not exploding for our entertainment. Comets do not return because humanity enjoys tradition. Gravity is not arranging eclipses out of kindness. The universe simply continues operating according to its own rhythms. We are the fortunate witnesses. That perspective changes astronomy emotionally. Instead of treating celestial events as distant scientific curiosities, humans experience them almost like invitations, temporary opportunities to step outside ordinary life and look upward together for a while, and over the coming decades there will be many such invitations waiting. Somewhere perhaps not far ahead now, T Corona Borealis may suddenly brighten in the Northern Crown. A star invisible to most people tonight may briefly become visible to millions. In 2027, enormous crowds may stand beneath one of the longest total eclipses of the century, while daylight collapses into twilight overhead. In 2029, Apophis will sweep astonishingly close to Earth, a mountain-sized asteroid visible from the ground while humanity collectively watches orbital mechanics unfold in real time. Years later, another asteroid will narrowly miss the Moon, reminding us quietly that the solar system remains active and dynamic rather than frozen. Mars will someday swell brighter in our sky than most living people have ever seen it. Halley's Comet will return once again, carrying thousands of years of human memory with it. Perhaps V Sagittae will eventually erupt dramatically in the distant future, while generations not yet born gather outdoors to witness a stellar transformation. And far beyond that, Jupiter's moons will continue their elegant gravitational dance, arranging themselves into patterns already written into the future of the solar system. All of these events are waiting ahead right now, already scheduled by physics, already unfolding invisibly through orbital motion and stellar evolution, while humanity sleeps beneath the night sky largely unaware. There is something deeply calming about that thought. The future sky already exists, not metaphorically, literally. The eclipses are already encoded into orbital geometry. The comets are already travelling inward. The planets are already moving toward future alignments. Reality is quietly preparing tomorrow's wonders in advance. And generations from now, future humans may look back on this era the same way we look back on historical eclipses or famous comets from centuries ago. People may ask older relatives, "Do you remember the eclipse of 2027? Or, were you alive when Apophis passed Earth? Or perhaps someday, what was it like seeing Halley's Comet?" Astronomy creates memories that way. Not loud memories necessarily, but lasting ones. A person may forget countless ordinary evenings throughout life, yet remember one strange, silent afternoon when the sun vanished behind the moon. Someone may barely recall entire years clearly, but still remember the exact feeling of seeing a bright comet hanging above winter trees. Rare celestial events attach themselves to memory because they temporarily transform familiar reality into something unusual. The sky changes, humans notice, and for thousands of years we always have. Ancient civilizations tracked eclipses nervously. Sailors navigated by stars. Farmers watched seasons through celestial cycles. Early astronomers spent lifetimes mapping planetary motion carefully enough to uncover hidden patterns. Modern scientists now predict events decades or centuries ahead with astonishing precision. But emotionally, we remain remarkably similar to our ancestors. We still stop and stare when something unusual happens overhead, still gather outdoors together, still feel awe, still whisper a little more softly beneath dark skies. Science changed our understanding of the universe enormously, but it did not erase wonder. If anything, understanding often deepened it. Knowing how eclipses work does not make totality less beautiful. Understanding stellar physics does not make novas emotionally ordinary. Knowledge and amazement coexist perfectly well, and perhaps that balance is one of the healthiest ways to experience the cosmos. Not blind superstition, not cold detachment, curious wonder, the kind that allows humans to understand the mechanisms while still appreciating the experience itself. Because ultimately, astronomy is not only about distant objects, it is also about perspective. About recognizing that human beings are part of something vastly larger and older than themselves without feeling diminished by that fact. The universe is enormous beyond comprehension. Yes, but somehow conscious creatures evolved on one tiny world capable of noticing it, capable of predicting eclipses, capable of tracking comets across centuries, capable of understanding stars well enough to forecast possible future explosions. That may be one of the strangest things in the cosmos, honestly. Not black holes, not quasars, not dark matter. The fact that collections of atoms on Earth learned enough mathematics to predict the future motion of worlds, civilization became very unusual. And tonight, somewhere above whichever place you happen to be listening from, the stars continue moving quietly overhead, exactly as they have for billions of years. Maybe clouds hide them from view right now. Maybe city lights wash most of them away. Or maybe you can see them clearly through a window or across an open sky somewhere. Either way, the universe remains active beyond sight. Some future eclipse is already approaching. Some distant comet is already falling inward. Some unseen asteroid is already crossing darkness between worlds. The next rare cosmic event has already begun long before humans notice it. Which means somewhere in the future, perhaps on an evening that seems completely ordinary at first, someone will suddenly step outside and look upward at something astonishing. And for a little while, millions of people across Earth will pause together once again beneath the same sky.